A, so I could cluster similar designs closer and move further these similar designs. And I introduced the PHR as a third axis. So I have closer to the camera the images that are predicted as more popular, and further those that are less popular. So X and Y axis, they are arranged using PCA, and the Z axis is using the PHR, which allow me to dispatch the images that are deemed less popular, but still keep a large aesthetic variety so the designer can make their own decisions and explore this latent space. And finally, this year I'm introducing PHR2, which is very different. First of all, it's a lot larger than the previous versions. It has many more input layers for different aesthetic qualities. And finally, it still outputs one single neuron as the PHR. Now, I'm using 13 different criteria, not only those from SAN and MSAN, but I'm also introducing brightness, Z-depth, percentage, and the fractal dimension for complexity. And now it's trained with a lot larger data set, which is a subset from AVA, from aesthetic visual analysis dataset. So AVA comprises 250,000 images, and I'm filtering only those related to architecture that are 12,000. So comparing the models, you can see that PHR2 is considerably larger model with many more neurons and exponentially more connections. And the data set is also considerably larger and broader in typologies. This is a graph plotting in the vertical axis the predicted output, and on the horizontal the real output. If it was a perfect model, we would have a perfect diagonal. But because we are dealing with aesthetics, which, as all of our colleagues know, it's not something completely black and white. It's a little bit more nuanced than that. I consider that it's a reasonable model to at least compare different designs. And here, it's interesting to note that the accuracy of the PHR2 drops a little bit in comparison with the 1.1, which I consider it is the price of having a lot broader data set for different typologies, not only pavilions in the park, but all kind of buildings. And just a sneak peek of what I'm using it now. I'm using it to compare design proposals for architectural competitions, because architectural competitions have sometimes hundreds, sometimes 1,000 submissions with tens of thousands of images. And I'm also using it to explore how generative models like Stable Diffusion are able to produce different aesthetic categories. So, for example, variations for this foyer, I can extract using Zoe depths, the depth of the image and the Kenny image, and I start to ask for all the aesthetic categories that we are familiar, if the model can produce them. So here is beautiful, comic, cool, cute, glamorous, grotesque, interesting, kitsch, maximal, minimal, picturesque, quaint, sublime, surreal, tragic, and ugly, and finally, zany. So again, I apply this aesthetic framework to be able to compare these aesthetic categories, and I can do a quantitative comparison among aesthetic categories. And finally, I can map them. So this is one visualization in which I use PCA to map them in a grid and show the different quantitative criteria. But more interesting, it is to see the clouds of images that you can see that some regions are very well populated, while others are not so populated. So you can see that, yeah, we can produce all these different aesthetic categories with a model like Stable Diffusion. But for me, what is more interesting is not to see the regions that are very populated, but the regions where it is unpopulated. So the next question is to ask, what aesthetic categories are dormant in these regions that we don't see any image yet? So this is what I wanted to share with you this morning. Thank you very much.
Vitor, thank you a lot. We have to move on to the next presentation. In the end, we hope we have a couple of minutes to make some questions. Okay, thank you, Vitor, for your amazing presentation. We will now.
Thiago, may,
Yeah,
let me
João,
just
go
say
ahead.
something. Sorry.
Yes.
I just want to let everyone know that we are live in Brazil and that we are also live on YouTube. So if you're not comfortable with sharing your image for some reason, just feel free to shut down your cam, or you can also tell me in the end, reach out in the end, because we can cut your part in the video, because we hope to make this available on the YouTube of ICCC. Okay, so just let us know if you are uncomfortable with that. We just ask that if you're presenting your paper, please have your camera on, so that's better for people watching. And I want to greet everyone in Campinas. Thank you for joining us. We also have a Discord channel that we can share with you, and you can participate with us. So I hope you enjoy this workshop and ICCC. Thiago, please.
Thank you, João. Okay, the next presentation is a short one, titled Symmetry-Driven Reciprocal Frame Algorithm by Caio Castriotto, Gabriela Celani, e Filipe Tavares. Go ahead.
Okay, thank you. So I'll share my screen and I'll start
Yeah, sure,
presenting.
Caio.
Let me see, share. Can you see it?
I can confirm we see it, yes. Go
Okay,
ahead.
that's very good. That's
Thank you.
very nice. Okay, so yeah, as you said, my name is Caio Castriotto. This was developed with Gabriela Celani and Felipe Tavares, both from Brazil. We have further developments with Olga Popovich Larsen and Zan Brown from Denmark that I will show a little bit at the end of this presentation. But first, I'll try to focus on the algorithm and yeah. So first thing, what is a reciprocal frame structure? It's not a very well-known type of structure, especially for people that are not from architecture or civil engineer. But this is a type of structure that we can see through history. Some author says that it's even in the first primitive huts that were built by humankind. Leonardo da Vinci also explored these structures with the Da Vinci Bridge. The same for Sergio's Floor by Sebastiano Serlio. The mandala roofs, mainly in Japan and China. More recently, we have the Zollinger system and the Hunenbeck system that is even made of steel. And here is a very contemporary structure from Mount Rokushidar in Japan. And you can picture more or less what is this type of structure. So we are talking about mutually supported elements. And the very basics is like we have elements supporting each other. They have a mutual type of structure system that one is supporting and being supported by another. And it creates an interlocked system, closed, that it structure itself. We can see it, we are somewhat familiar with it because of card boxes that we usually use to move out and to different places, that we create this pattern. So the basic composition of this type of structure is called the fan, and it's built by at least 3 different linear elements that we will call it as an XOR. It is a definition by Bavaro. And the usual approach to design a reciprocal frame structure is to solve the centricity between these elements by precisely overlapping one element with another and tying everything together. There are a few computational tools that handle this at some degree, but it may limit the geometric exploration possibilities for this type of structure. So what we try to do is to find a different approach that will not focus on the eccentricity and will try to focus on a geometric pattern. So this attempt we developed by studying wallpaper symmetry groups defined by Conway, Burgio, and Goodman-Strauss. That focus on creating a reciprocal frame pattern that can adapt to different geometries in which the designer has more control over the outcome. And this was implemented as an algorithm in Grasshopper, a visual programming tool for rhinoceros. Important thing here is that with the approach that we solve everything by eccentricity, sometimes we don't have a very good control over the outcome because we need to position one element overlapping the other. And this creates a more rigid strategy, and we try to go to a different way. So I don't have the time to explain with details what are wallpaper symmetry, but we can say that it classifies 17 distinct wave patterns that can repeat on a flat surface, and these will be combining translations, rotations, reflections, and light reflections. And these operations, these geometric operations, are shown in these 5 types of cells. And we can combine the cells from the wallpaper symmetry groups with the kind of pattern, the basic pattern of a reciprocal frame that can be just an XOR or a fan. And by combining these, we can find different types of symmetry groups. And we found 9 kind of normal standard patterns and 2 special ones that are the 2 last ones at the bottom. And we try to define or find the limits of what we can or we can't do with reciprocal frames. And for our initial approach and trying to solve the initial things, we focused on the quad fan rotation pattern that is basically a fan made of 4 different nextors, and they are rotated in the center of the intersection points from a mesh that I'll show next. So to understand this and to build this as an algorithm in Grasshopper, we first needed to understand a little bit better the data structure of the elements, and we actually found a pattern that we can use to extract the index values and position and correct adjust each line to generate our reciprocal frame pattern. So we can, if you look a little bit longer to these images, you can start to find the patterns of distribution of indexes in each line. And so first we needed to take what we wanted to use for a reciprocal frame, and that's the inner lines. So we wanted to generate a mesh and remove the outer lines and the corner lines that we are not going to use in a first moment. And from these lines, we could split it into the 2 main directions of a mesh or of a based on a NURB surface. That is the UV, very similar to X and Y, but this is for a surface that can be curved or not. And from that, we could start exploring some geometric possibilities. One was the rotation. We could change the rotation of these lines to generate a reciprocal pattern. And we could also create extension at the core, the outer lines to and it may be bigger or smaller. And then we create a set of geometric operations. These operations are based on arithmetic progressions because we needed to adjust and combine the correct line with the correct congruent plane. So if you look at the first image here, you see that we have lines that we call it AU, the green lines, and they have to intersect with the planes BV, that are the pink dotted ones. But if you look at the last ones, then we have the lines BV, congruent to the planes, same name, but they have to intersect with the lines in BU. So we had to adjust these intersections and find the correct values. And with that, we could find with the correct intersections, we could reconstruct the lines with precise length in order to generate the reciprocal pattern. And of course, on a standard pattern, this length is the same. But if we change this to a complex geometry, these values, this length will change, and we needed to have the correct, precise length to generate the pattern. Then we could use this line as the axis of our nexors, or linear elements, that then can be moved and extruded by a thickness and a height value to generate the 3D geometry of the nexors. So if we look, this is a quick overall look at the algorithm. And if we look at it, we have two important information. One is that all or most of the operations are purely geometric. We really don't deal with the eccentricity. And the second is that we have control over 6 parameters. From the density of the structure, this is the amount of elements that we are going to have, and the rotation angle, the thickness, and cross-section values. And this is basically the process. Then we have a NURB surface, freeform surface that may be complex or not. And we apply the algorithm, and the outcome is this structure with all the 3D elements. And in this case, we even have elements that rotate by a variable range of values that is from 9 degrees to 29 degrees. And the density is 12 in U and 10 at V. So here I want to show a little bit further of the paper. The paper initially ended here, but I wanted to show a little bit more to explain a little bit better what we are doing. So we created a special type of connection system for these reciprocal frame structures that is a clamp connection. And here is the algorithm working. And note that it is very important that this algorithm will have errors, but it is important to have errors so we know the limits of what we are doing. So we can basically explore as much as we want a structure until we reach a point that it's not working anymore. And we can change pretty much all the parameters as much as we want. So I'm changing cross-section now, thickness values, rotation angle. Yeah, and then we can also adjust the connections. And then we could explore this with students, giving different freeform geometries, applying the algorithm, and creating small-scale models to understand this type of structure and understand what are the limits and how we can build different types of reciprocal frame structures. And we can also combine this with structural evaluations from Caramba, also inside of Grasshopper. And this will change and give us these different design ratios, values for buckling, for deformation. And we can combine this with our geometric exploration to understand where we are going and what are the limits. So we built some pavilions already. This was in Denmark. This was the first one. Then this was the second one that was for an exhibition. We built one also here in Brazil with a bunch of students they were using the algorithm and we were trying to explore different possibilities and understanding tectonics. So at the end, we can explore possibilities in different geometries, generating different patterns and really enhancing and trying to go further in the exploration and the creativity with reciprocal frames. Here are the references of the paper, and I thank you for your attention, and I think I got everything on time.
Thank you, Caio, for your amazing presentation also. And sorry for the noise here.
No worries.
So Thank you again. We will now move on to the third presentation, again a short one, entitled Ruled by Utopia, Procedurally Generated Megastructures, by Guilherme Almeida, João Cunha, Sérgio Rebelo, and Tiago Martins. Guilherme, can you start sharing your screen, please?
A moment.
Yeah.
Okay. Should be working fine.
Yes, it's working. Yeah, go ahead.
Perfect. Okay, just give me a second. Okay, so hello everyone. My name is Guilherme Almeida, and I'm here to present our pictorial on procedurally generated megastructures. This work falls under the umbrellas of procedural content generation and procedural generation of buildings, and our main goal was to design a building generation system with a strong focus on aesthetics and ideation potential, rather than being concerned with the feasibility and the functional requirements associated with buildings and living spaces. One of our main inspirations for the current implementation of the system was the work of Van Aragão, especially the vertical reclamation of individual spaces series. These buildings present a series of interesting challenges for a generation task, such as the various scale of floors, the irregular profiles, and the variety of elements and modules present. Other characteristics we wish to emulate and bring over from these buildings are as follows: their verticality, their monumental scale, their busyness in terms of design elements and the smaller structures within them, and their surreal look. The buildings are somewhat surreal, but they look perfectly feasible at a glance. Only with a closer look can you actually see the intricacy and the impossibilities or incongruities of the buildings. Here's some more examples from that series of illustrations. Japanese metabolism is also a big source of inspiration, somewhat derived from the first one. In the picture, we can see the Nakagin Capsule Tower, which was unfortunately demolished recently. Here, our main interest comes again from the verticality of the buildings, their modularity, which will be even more apparent in the next slide, and this concept of towers, of these separate sections that operate individually, but that can still share some characteristics and DNA with each other. Here you can see the modules I mentioned before, especially on the left side image, as well as some more examples of the Japanese metabolism style. Given our set of target outputs, we decided it would be best to abstract a common structure for all buildings, and therefore each building contains an X number of sections, these larger parts, which contain an X number of towers, which contain an X number of modules. This is the structure our system is operating upon. For the approach itself, we start with the user inputted rectangular surface, which is split according to a simple generative grammar, and generates a series of smaller sections to build towers. At each cycle, the system goes through each existing surface and picks one of the rules to apply, while also reducing the probability of a non-terminal rule to avoid having very thin and hard to use towers. Once we have those, each terminal base is extruded, and these fillers, these structures we call fillers, are added to create a more logically sound base for the following section. And the bounding box of all those taller towers serves as the next base. So this is an outline of the construction steps. As you can see in the third and fourth models, these filler structures, there's a parameter called filler height tolerance, which gives us the height from which these towers are re-extruded. And if we try to place the following section only on that small red square, it wouldn't really work and wouldn't look very plausible. So we re-extrude some of the towers to create a more sound base for the following section. And lastly, the non-visible parts of the walls are culled to avoid unnecessary or invisible modules. And then we create a series of bins in terms of width and height to create a point grid with an appropriate size for the wall. And then the modules, the user-defined modules, are distributing according to a 3D simplex noise space. The current implementation also allows for any number of user-created modules to be designed and applied to the building. And after this step, the generation is done and we get results such as these. Each of these images has two examples for a given set of parameters in the system. Here, for example, the main difference between the two sets is precisely, and as I mentioned before, the value for that pillar height tolerance. A lower value, as shown on the left side, creates more recesses and a more irregular profile, while a higher value keeps everything nice and tidy and more like a regular building. For these two sets, the main difference is the contraction and expansion values for the section bases. On the left side, once each section is generated, the starting base can be scaled up or down, creating this undulating effect in the building profile. On the other hand, the right side's building section bases can only scale upwards, meaning that the building will always tend to become wider as it goes up. A few other differences are the number of sections and the possible height values for each of those sections. The left sides are typically higher and have a wider range of heights, while the right sides are typically shorter with a constant height. Lastly here, the system currently supports any rectangular shape as a starting input, although more extreme shapes may yield less than ideal results. We'd also like to add that we've tested 3D printing some of these buildings. At this scale, the 24 centimeter max height scale, the buildings print quite well, though some more complicated modules than the ones we've used could lose some quality and would have to be printed at a higher scale. We also see quite a lot of potential in using these buildings as standalone illustrations and graphic design material, or for example, as paint by numbers kits, assembly kits, or ideation tools for architects and artists. Lastly, for this section, I'd like to draw a comparison between our current implementation and one of the target outputs. We believe the system works quite well at this stage when it comes to the general structure of the buildings and their profiles for this style. The system allows for quite a bit of control and customization from the user. Not only that, but we believe that the current implementation already allows for a wide range of variety, both between different parameter sets as well as variety within each set. However, there are still some improvements to be made, namely reducing overlap between modules and fixing some irregular placements that can still happen. Improving the generation time, because although 20 seconds is not too bad for a non-real-time application, we believe it could still be improved. We'd also like to work on a greater integration of generative grammar techniques, which we believe could lead to more structured and interesting results when compared to the noise-based placement, and will allow us to create different grammars for different target styles, not only an octagonal style, but other architectural styles that we also want to work on. We'd also like to add more architectural features and other types of decorations to the buildings. And this concludes my presentation. If you have any questions, comments, feedback, perhaps some nice words to say, feel free to email me. I greatly appreciate it. And thank you all.
Thank you, Guilherme, for your presentation. Now, the next presentation is a long one by Provides, entitled Decentralized Indexing in Common Data Environments for Collective Actions in Urban Design, a Blockchain Proposal. I'm trying to find, Provides, you are here. Hello.
Hi.
Hi.
Yes, can you hear me clearly?
Yes.
Awesome. Okay, let me share my screen. So hi everyone, thank you so much for the introduction. I'm very happy to be here. Today I will be presenting a blockchain proposal on how we can become an architectural common. So in today's digital economy, it is very dominated by centralized platforms like Google and Facebook. They offer a free computational service in exchange for your surrendering of data, which they then use to control how information is ranked, harvested, and monetized. And while Google offer a lot of convenience in our lives, including mine, but users actually have very little to say of where the value of their attention or data actually goes. Also, not much exists outside the reality of their management model, which means that there are very little choices for us as consumers. In the field of architecture and urban design, decentralization can benefit data collection for projects like Sidewalk Lab, which is by Google, which has the ambition to build the next data-driven city. However, as much as they would like to invite citizen participation and data contribution, their proprietary model often drives public consultation into tokenistic outcomes and causes common data environment to remain siloed. This actually creates a very serious disconnect between designer expertise, algorithmic models, and real-world community needs. All of this is mediated by ways in which information is ranked. Our built environment actually deserves better, more inclusive, and equitable participatory methods. And I would say that at the core of the problem is the lack of means to collectively discover the value in a piece of information and the ability to collaboratively rank them. So imagine this scenario, there's an architect, you're the architect for a building project. You have collected 10,000 pieces of citizen inputs, and you have to search through this data environment for the most valuable piece of data that can inform your decision of, let's say, how to design a child-friendly space. The first piece of information that comes up in your search would greatly influence how your decisions are made. But what actually determines which information came up first in a search? For instance, here we can see because data point A and B came up first in my query, these two pieces of information might determine my decision, and thus the decision space. So this is how information ranking deeply connects to governance and decision-making. Now, of course, we can hire a project assistant to rank the information, label them one by one, but we will still run into the problem of defining more subjective parameters and defining the quality in the design. Along these lines, the study investigates two interrelated questions. First, how can value be transacted from peer-to-peer amongst a network of content contributors through decentralized indexing? And consequently, how can value be captured and realized within this data transaction and in what form? So this is what the study proposes, a decentralized information ranking method, which is essentially a collective indexing infrastructure that turns any data environment into a peer-to-peer system. And the core innovation here is what I call the proof of architectural work. So in most decentralized systems like blockchain, they use a proof of work mechanism to assist the community to reach consensus by validating the legitimacy of a computational transaction. But it heavily relies on whether an individual has the computational power to actually participate in this mechanism. So for instance, if I can afford a better GPU, that means that people with higher financial capacity can more easily influence the system. And financial speculation is a tool great for the world of investment, but when it comes to architecture, it becomes a problem because excessive speculation can cause a lot of damage to projects that should be human-centric. So the proof of architectural work mechanism leverages the concept that one has to contribute some level of work or computational power to participate, but still be able to use the power towards enhancing built environment quality. And here's how. For instance, you can contribute data points, OpenStreetMaps, LiDAR scan, social analysis, or design ideas and contents, or compute like lightweight storage and processing on your computer. And by contributing these to the system, you can enhance your stake in influencing the system decision. You will be able to vote on a piece of information, so to rank them collectively. This basically generates a decentralized consensus. And you can also earn rewards if someone voted for your contribution and your design. So what this creates is a data for data, compute for compute ecosystem where a network of competing designers can actually create harmonious outcomes. And I will give an example to illustrate how it actually works in action. So here's a demo of the indexing interface. For instance, I searched for Omniverse demo chair. And we can see that chair 3 USD came up first because 2 people voted for it. And all of the other retrieval ranked less. So as a creator, I can upload my demo share model to this platform, which is a common data environment. Backers can vote up which model they think is the best by storing a JSON file on their local device. What this does is that the community contribute the storage power to form a distributed database, a yellow page of which query comes up first. And their vote will directly influence which piece of information come up in the search. And this can help them to attract attention, clients, collaborators, and harness network effect. So essentially, the three core agents in the system is creators, backers, and clients. However, this is also a very basic decentralized autonomous organization model, and all of them faces the same problem, which is the DAO hack. There are loopholes that lead bad actors drain millions of dollars by attracting people to vote for scams. So this is the core problem, which I tried to mitigate. It's called bad voting, that the community actually doesn't have the professional knowledge required to make valid decisions, for instance, construction projects, and they cannot differentiate between a valid proposal and a scam, and it causes the system to fail. And what I think is essential here are three additional mediating agents that can help to guide the process. First is a validator to deploy building information modeling to align real-world constraints with idea proposal, so they can tell us whether the proposals are actually validated. The second is an iterator. It will consolidate all of the recorded history, including users' votes, expert evaluation, BIM simulation, and generate evolution of the design option so it can grow into maturity and a Nash equilibrium. And the third mediating agent is a diversifier. So it's not enough to just eliminate false proposal. It's even more important to introduce good proposal in the system. And so the diversifier takes an idea seed and generate exponential options of that seed so it can flood the system with better designs. And this is where generative AI comes in handy. And I try to demonstrate how this can work with a case study in Hong Kong. So this is the new development district in Hong Kong, and it's designed through the transit-oriented model, which means that they really value the transit hubs within the urban fabric. And it's a very network-driven approach to planning, which makes it a great case to actually utilize a graph-based diversifier to generate more ways in which urban fabric connects with each other. And this is a very simple test that I've done. I've utilized 4 different graph models: E8 graph, random graph, small world graph, and preferential attachment. As you can see, because their degree distribution, clustering coefficient, and symmetry are intrinsically different, and so they are good for different planning models. For instance, E8 graph is good for conceptual design of symmetric urban or cultural hubs. Random graph can be used to diversify unplanned or evolving connectivity. Small world graph can help to optimize local clusters, and preferential attachment can help to model hubs, emergence, and growth. And by utilizing combining idea seeds and generators, we can diversify planning option according to the complexity of existing fabric, or use this as a datum of evaluation according to predefined objectives. Now, of course, this is a very, very simple test, and I'm sure computer scientists can do it better than I do, but essentially it demonstrates that for a successful information system, we need 2 core elements. First, we need entropy calibration. That validators and diversifiers are not competitors. They are competing agents with collaborative outcomes and help the system achieve equilibrium. For instance, an AI user can maximize entropy of the system by providing more options. A BIM user can minimize entropy of the system by providing results of visibility. And together, system entropy maximizes globally but minimizes locally. And this is how intelligence was defined by Norbert Wiener in 1948 cybernetics. And in the system, blockchain manages entropy by acting as a directory at the infrastructure layer. But I'll also like to conclude by saying that the decentralized indexing, it's not a database. It doesn't store information. Instead, it's a yellow page that directs you to important information. And second, it's very important to note that while the system is decentralized, it has a certain level of centrality through users' votes. And this is based on an evidence-driven mechanism to create informed decisions. Finally, and most importantly, proof of architectural work is not a proof of stake. It is not meant for financial speculation, so you cannot buy your way in, because a piece of work is defined to be a piece of contribution in the form of content or compute. Therefore, in this decentralized system, the goal is to enhance built environment quality, not to maximize profits. To conclude, the study basically proposes three things. Technically, it tries to merge blockchain, BIM, and AI into a decentralized stack. So then we can enhance participation of different stakeholders. And second, socially, it tries to enable transparent participatory planning by preventing bad voting, so that users pay with compute to enhance their awareness and responsibility of their choices. And finally, economically, it creates a market for data and computation. It's not just monetary. So it is more than a system. It's actually a paradigm shift of how we participate and enable new forms of value circularity. And finally, to conclude, by democratizing indexing, this study hoped to empower communities to build environment they validate and value, and move towards an architecture of collective intelligence. Indexing isn't just a technical endeavor, it's a form of social economic engineering. So in the next step, I intend to test this system proposal through behavioral experiments in the real-world community context and validate whether what I anticipated will actually happen in physical reality. I always welcome collaboration, so don't hesitate to get in touch with me if you're interested. Thank you.
Sorry, I was muted. Thank you for your presentation, Provides. We will now move on to the last presentation, a short one by Yidi Wang. I hope I pronounced your name correctly. Sorry if I didn't.
Yeah. No worries.
Okay.
Thank
The
you.
presentation. Sorry. Yeah, you can start. Okay. One little detail. Sergio is showing a QR code to help you joining our Discord channel. Okay, of the ICCC. You are welcome to join. Yeah, it's just to provide a little context to the image that you are seeing. Okay. Now, yes, the last presentation entitled Artificial Synesthesia in Tension between Sonic and Architectural Composition, Intelligent Computational Infrastructure, and Stochastic Redundancy.
Thank you. Yeah, so I also shared our website in the chat. So if you want to open it, you can also have a look.
Sure,
So
thank you.
for my presentation, I'll show our website, which is also our main platform to gather the practices. So it's based on the title that you just read through about sonic and architectural composition, and then now we're extending further to artistic practice and also sort of a decentralized governance model to work with policy people who are based in the global south. So yeah, and this is the front page. And this one is about our the latest exhibition will be in Milano, and I curated this. It's called Mesocosm, Room as Policy Making. So we gathered group of artists. They could be digital artists and etc. And one of the painters, she did a series of oil paintings about rooms. And based on my experience or knowledge in architecture, and I'm super interested in how room could be a metaphor or even a real model for policy making, like the starting point. So we do not only think about the policy making. For example, in Europe, we have the Euro stack, but that is basically a very fundamental cubic geometry. It has nothing really, maybe different layers could be separated. So we're thinking from more mundane, even everyday scenario, how can we think of policy making and for example, in the room. And this one, if you see the colors, also the website is very colorful. This is a theory of mediation from our researcher. She's a mediator based in Germany and Vienna. So this is basically how we can, think of the way to build better relationships between, individuals and organizations and etc. It also contains a lot of different levels of how we are living our life and forming relationships, etc. Even some very interesting poetic language. I think it's very interesting that we can show people how we can start to reach out to maybe policy people using informal language and experimental ones as well. So that's the whole intention of our starting point of Eternal Terra Year. Yeah, and for this one, you see that this poster, we also want to extend further from individual room. We want to investigate further into how oyster structure, for example, this kind of a living organism is geometrical structure could be very inspiring in our understanding of the relationship with the ecosystem, how nutrition and oxygen, etc., is transmitted through their geometry, and I mean, there's all based on aesthetics and architectural understanding, but we can actually extend it further into other region, other fields. So that's basically also the main point of this practice I want to show you based on the theory and paper. You can find out in the website as well. So our organization is also nonprofit. We want to register in Belgium, also Hong Kong as well. By the way, I also was from the same university, from Provise, and she actually taught me before when I was maybe 2 years ago. So now, and now we're basically based in Europe, and we also interestingly doing the decentralized governance model, and but it's not only based on how architecture is built, but further through activities like education, art curation, and also we talk to the NGO people who work on humanitarian aid and refugee support, etc. So we overall want to provide a trust, a mutual aid system, and this is kind of a system. It's also a way to realize a decentralized modeling or architecture. We call it social architecture. So yeah, we also want to deal with financial model. And yesterday I went to this exhibition about geopolitical infrastructure in Antwerp. So there is also a very interesting organization within the exhibition. They call it Alternative Way of Funding. It's based in I think in Middle East, but the concept is also very interesting. So we also want to provide financially to tackle the current world system that we are in. From even artists, we can start to think about it. And for this one, I want to introduce you our PhD researcher, Caroline. She's also a sociologist in alternative finance and deep sea mining. So we investigated in this research. You can also open it further if you go through the website about the deep sea mining industry, how it's interconnected with other industry in the mining and ocean-based financial system, etc., and how it's interacting with the ecosystem from maybe even smaller marine animality perspective. So it's all within this, macrocosm even. So our scope is quite wide, but in the end, we will compile them together and find a way to show it in the exhibitions. And together, we also a think tank. We have, communities spanning different regions. It's very interesting. I just sent this LinkedIn post, and people mostly work in policy making. They start to reach out to us, and we interviewed around more than 50 people. And now we just invite their NGO, their organization, for example, from Bangladesh. They can just show us what they're doing. And also oftentimes their NGO is very international, maybe connect to Australia and etc. So yeah, it's very interesting to see how people are functioning in this way. In terms of the original research in sonic and architectural composition, I actually also extended further. We had a conference in IRCAM. It's basically maybe you'll be interested in this. I mean, not all of us are architects, but this is an institute in Paris set up by Yannis Sinakis. So he work with Le Corbusier a lot, and he's both a musician and an architect. So his project, I mean, last century is about computational music. So we had this conference there, and this year actually 3 months ago about about this topic. Basically, I invited Jessica. She's a policy consultant from Sustainable Ocean Alliance. At that point, I was researching about the ocean, so we were trying to do an open call or have a conversation with the sonic engineers who oftentimes also do, for example, specialized music, specialized sonic composition. It's very interesting if they can start to reach out to, you know, sustainability and how to think of the current world system of renewable energy, even from basically to use all the resources and using their skills, how to do the modeling in different abstract of versions, not only geometrical, but geometry could also be a, you know, object score and in sonic in music field. Hello, can you hear me?
Yes, we can. Thank you for your presentation.
Oh, sorry, it's not done yet. Just the screen is.
We are still listening to you.
Yeah, I'm just waiting for the screen because it's a video, so I couldn't really move at the moment. How many minutes do you have?
You still have 2 minutes. If you prefer, you can stop sharing your screen and restart the sharing if you want. Sometimes works. Not guarantee, but give it a try.
Yeah, I think it works now. Yeah, perfect. So this is the primary research I submitted through your conference, you know, and you can go through it. It's also connected to the foreign object. It's a posthumanism philosophical lab. So we're all, you know, connected interdisciplinarily. And we also have journal ongoing. For example, this one, he's an artist, but he got this very rare disease. But it's not rare. A lot of people get it. But the fact is that in Germany, the current health system is not really helping to tackle the Lyme disease, for example. And then Gia, she's before also architect and now working as a artist. And her work is about urban slam and also traditional nature plant-based dyeing skills to make fabrics, as you can see in the background. Yeah, so we also want to provide consultancy and provide diplomacy method, but from non-nation state perspective. So we are grassroots and we also connect to other grassroots organizations. Yeah, so if you want to go through it, feel free. And we have also, in terms of computation, which is more relevant to this conference, I had the research in Sciences Po in Paris. We were doing, delving deeper into the EU DSA framework, which is the Digital Service Act, how to regulate Meta, such big platforms. They oftentimes they have to do policy to regulate their content, and we are specifically focusing on greenwashing content, so which means environmental and digital regulation at the same time.
Que eu precisaria para amanhã, que é uma coisa relativamente simples, que é colocar os endereços.
I'll try to mute this MacBook.
Okay, great.
Please continue.
So yeah, we have some also affiliations to the citizen science association. So I realized, you know, oftentimes this NGO, they provide frameworks and they need people to put into content, you know, and then we overall have a game, have an aim, have a goal, which is citizen science and decentralized, blah, blah, but they need people to really do the creative job. So I think we can basically also reach out to this field if you are all interested. I think currently the world is changing. So also in terms of digital and environmental regulation is a new field that people are working on. So why can't architects and artists also work on it together to think about the future policy? And we have also some upcoming events, including today and some exhibition. If you have a local space in your area, we're also gonna have a fundraising for Palestine in Mexico, but in Brazil we are affiliated with, you know, people from, I believe, in South America because of IAC. I'm also affiliated with IAC in Barcelona. Some professors are from there. So yeah, if you want to do something with us, feel free and visit this website. We want to make it a platform among us. We share resources, and we also want to make it a democratic interface.
We'll have to conclude, Vidi. If
thank
you just want to say some words, okay, thank you. And sorry for interrupting you, okay? But
yes,
we
that's
have
the
4
last
minutes.
page.
4 minutes at least to read some questions here that I found in the chat. And we'll start with the first one, a question to provide, okay, for you, actually. How do you think aesthetic preferences can be incorporated in your participatory system? This is a question by Victor.
Yeah, it's such a trick question. Oh, yeah, but obviously I love it. I think it also, the complexity also depends on context and the situated understanding. For instance, I work a lot with public housing communities. And obviously, aesthetic would be determined by education level, age, generational parameters, and things like that. So it's quite subjective. Within such participatory system, if we say we do it completely distributed way of voting what people think is pretty, you can easily imagine that all of us will be out of a job immediately.
Yeah.
Because designer were trained to appreciate aesthetic in a very different way than people who didn't receive the training. So it's essentially a democracy problem, right? And it's not something that I have a question to, which is why what I proposed was that we can have some sort of adjudicator system that can balance between a common appreciation of taste and style with a more expert-driven appreciation of taste and style, and maybe work with Victor to also have a machine appreciation of taste and style. Together, it would be something definitely bigger than what we see right now. And I actually have the same question back to Victor. What does it mean for us that machines can understand beauty? What does it mean for us as designers and architects in that sense?
Yeah, I think that the first thing is that trying to optimize the following aesthetic preference, it's also very dangerous, in fact, because sometimes the most interesting architecture are the less enjoyed. So if you think something like the Jewish Museum by Libeskind in Berlin, yeah, it was not very popular, but again, it's one of the most interesting buildings for the last 20, 30 years. So I'm not sure that trying to reach the most popular aesthetics is something that we should foster as a discipline or as a practice. And then replying, yeah. So we do participatory, but how much participatory we do it, right? It's always tricky. So I ask you that because I don't have that answer. And then replying to your question of how does machine understands of aesthetics fit or comply with human understanding, I don't think that the machine really has an aesthetic experience because it's simply right now, in my case, a neural network that is multiplying through many layers and many neurons. And I'm pretty sure that when you are visiting a building or watching a movie or listening to a song, you are not doing multiplication, hundreds of thousands of multiplications. You have a completely different process in your brain. However, oddly, it can approximate how people prefer one object to other.
Yeah.
So I think it's useful to compare aesthetic objects, but it's not really um, simulating what we feel as an aesthetic experience.
Yeah, thank you, Victor, for your answer. I have a question to Caio, if possible, of course. A personal one. What made you choose symmetry as the main or as one of the main ideas for your algorithm, let's say?
Yeah, this is a good question. When we started to work with reciprocal frames, we realized that we could take one element like an actor and just rotate it around the central point, and it would generate something similar to a reciprocal frame pattern.
Okay.
Then we started to study a little bit more on how to create these patterns. And what we found on the literature is that we had some patterns already well established,
Mhm.
but we didn't know what was the possibilities, where, like, how we can choose a pattern, which pattern is more interesting visually or geometrically. And then we decided that it would be interesting to study reciprocal frames from a geometric perspective. And by that, we decided, okay, if we need to choose a pattern and if we need to understand this pattern, we need to establish which patterns we can study and we can understand.
Mhm.
And then we try to create a systematic approach. And this is how wallpaper symmetry came
Yeah,
to aid us and rescue us in our research
makes
question.
sense. Makes sense.
So it was like from reciprocal frames to a geometric perspective instead of a geometric perspective to reciprocal frames.
Yeah. And I have a follow-up question also related to symmetry, so sorry for that. But do you
Yep.
think that symmetry makes the structures more beautiful, let's say, or aesthetic appealing, or just easier to design?
Yeah, I would say that one thing that I consider in the full paper is non-Euclidean symmetry. That is a type of symmetry, but it's not the symmetry that we are used to. It's a symmetry that works on digital spaces more often than in physical spaces. It's almost impossible to have it in physical spaces, but we can have some abstraction of it and create symmetry that is you can see a symmetry, but it's not exactly the same. For example, on both sides, it has a distortion or something like that. I think aesthetically it has an appealing. It is interesting to see something that has symmetry, that has a geometric study, than something that has not. So, and reciprocal frames, I'm a little bit biased, but I think for me it's a very pretty type of structure because it's different from what we are used to, and at the same time it has it's at some time like you have so many elements, but at the same time they make the whole. So
Yeah,
I really think it has an aesthetical value.
totally agree.
Um,
Okay.
yeah,
Okay.
maybe I can use some of Victor's research to evaluate the aesthetic
Why not?
composition of Victor
Why not?
frames. So yeah,
Thank you, Caio.
thank you.
Small question also for Guilherme. Guilherme, uh, I have two questions. I'm selecting one because we don't have time. But do you see your tool as something for inspiration or something more? And if something more, what? What do you have in your mind for the next steps?
I think for now it works well as an ideation tool, but I do think it could be applied to more things. If, for example, we could reach a point in which it could be, I don't think even a real-time application is needed. But for example, for map design for video games, I think it's an interesting avenue to pursue, something that I'm interested in. I also think it would be fun to explore with using different types of inputs, for example, sound or other images, as a way to control the parameters. I think that would also be interesting to try out. And Victor actually gave me an idea as well to use ControlNet and Stable Diffusion to generate different types of images. That's something that I'm also willing to try out.
Okay.
So yeah, I think there's a lot of potential in this tool, and I'm excited to work on it.
Sure. Okay. Thank you, Guilherme. And the last question, a short one for Guidi, the last author, last presenter, let's say. Your work, at least your paper, I was reading it, discusses both anxiety and aesthetics at the same time. Can you tell us a bit more about how these two, in your perspective, connect?
Yes, I was just writing about something about anxiety. I think it's widely existing because of the current world system. Also, why we need more decentralized approach to be participatory, but that's also how we approach both. For example, if we are sitting in a room and it's like internal area, and then there's definitely distinguish between inside and outside, and it's also related to the object-oriented ontology, and the founder Graham Harman, he quote a lot from Bruno Latour about the network, but but even within a network, in between objects, there's always tension. I mean, it's based on physics and etc. If we want a more fluid composition to make the world system better, and then there's always tension. I don't think the composition itself is fixed, which means the aesthetics is not fixed. Therefore, the machine cannot, just imitate by repeating and etc. So I think tension is actually and very essential in a better world system, and a more deeper understanding to maintain the aesthetics. And but we always and oftentimes have anxiety to change to tension. So I think the way we see anxiety itself, it could be a tackle point to understand all of this within our mental state already.
Okay. Thank you, Edie.
Thank you.
So we are already 8 minutes late. Let's thank the presenters for their insightful talks. Okay, these claps are a bit strange for me, but okay. Thank you all. Okay. Not sure how much time, Sergio, do we have for the next presentation? For the next section, not the next presentation. We'll be in.
Give me a second. We're scheduled for 10:30 Campinas, 14:30 Western Europe, 15:30 Central Europe. So I don't know. I maybe would suggest we take at least 10 minutes human needs break.
A little break, yes. I believe all of us need the break. So thank you all. Okay, I really was like, I was really liking to see the messages and the discussion in the chat. Perhaps a big project, yeah, if I understood correctly. So let's keep in touch, okay? And thank you all, and see you in 10 minutes, okay?
Yeah, enjoy this break, and we will leave the Zoom open for you, and the people in Campinas, feel free to just continue joining. We'll leave this QR code online. We have the Discord channel, we can continue there. And yeah, we'll be back in 10 minutes.
So, bom dia, good afternoon, guten Tag, and welcome back to session 2 of our fantastic program this afternoon at ICCC'25 on computational design, computer-aided creativity. I'm Jason Reitzner. I'm chair of foundational media design at the International University of Applied Sciences here in Germany. First of all, welcome to all of our panelists this afternoon. We're going to be looking at 8 presentations in the second panel, going until 12:30 Campinas time. So we're going to be starting off, I think, with Aleit. Hi, good afternoon. If you want, I think you have screen sharing enabled. If you prefer, you can try to get your presentation up and running. And once we are ready to rock, then we will get started. As I said, as in the last session, we will be holding our questions for the end and then doing a Q&A together as a team at the end of the session. So short presentations and pictorials, as in the last session, have a duration of 10 minutes, and long form papers a duration of 15 minutes. So please, feel free if you have questions during the presentation, write them up. Definitely feel free to put them in the chat, and then we will look at the chat once we've heard from all 8 of our panelists this afternoon. So I see that we are ready to go. Aleit, when you are ready, you have the floor.
Okay, cool. Bom dia to you too, Jason, and to everyone. So I'm Aleit, third year PhD student at Northeastern. Working with this great team in Northeastern's AI Skunks Works team and the Ghost Lab. I have a palm tree here. It's not a logo, but it's just for Brazil. And so this was the research team. It was myself alongside a typographer, a professor that sort of like runs this sort of like a group of students that do innovative projects, and then an undergrad that I was mentoring alongside my advisor. And so just to give a bit of background on AI Skunkworks, it's a Skunkworks in itself is a project that's developed by a small and loosely structured group of people who research and develop a project primarily for the sake of, I'll put it in quotes, like radical innovation of sorts. And so this is where this idea of the project was made to be, and that's what I'll be facilitating as I go forward. So this pictorial, what I submitted to the workshop, was originally published as a tiny paper at ICLR, the International Conference for Learning Representations, in 2023. And in this workshop, what I'm really doing is transitioning what I had into what is a matter of responsible design. So I'll get into what the topic means and also how I'm transitioning it towards this subject. And so I submitted this image as part of like the intro to the pictorial, which is when you have an AI system, which is the computer that's sort of in all parts of a creative designer's workflow. The typographer feels like they're being replaced, and then the creative AI designer comes and they're like, okay, responsible designers are here, and then other creative domains might eventually follow. So that's sort of like the idea behind it. And so the research procedure, just to get into it, I started off with conversations with our typographer. This was 2 things. So we had a typographer that was in our team. And so the first thing was to understand the field of typography. Obviously, they're the subject matter experts, and we wanted to solicit their knowledge. And then second was to understand salient needs of what the field of typography needs with the incorporation of AI into their workflow. And so I'll go off with a brief history of just to like situate the project a little more, and also because that's where we sort of found our research gap of where we wanted to implement our work. And so, so typography has been evident since the hieroglyphics, which was in Egypt. And since then, replicating text via movable type has also existed with woodblock printing, such as what we see here is a manuscript from the Tang Dynasty in China. So this is not necessarily from the Tang Dynasty, the image I have here, but sort of looking at the invention of woodblock printing that helped to sort of really bring writing and types into a larger sphere. And then going into the Latin type, we see that typefaces emerge as calligraphy was overtaken by the incentive for mass production. And in the history of Western printing was inaugurated by the letterpress around 1450. So, and it's an ontology, Latin typefaces are mostly named after the people that devised them, such as Garamond, which was the Parisian engraver Claude Garamond, and then also movements that inspired them, such as the Roman, which foregrounds the Times New Roman in Italy. So then later on, some formalizations came to be, which was when we came across this idea of a serif. which is a projection of a stroke on a letter, and I'll show this in a little bit, which was introduced to mitigate the confusion one might have between, say, the letter L and the number I. And so this is where different typefaces came to be, where you see here the serif, you have that little stroke underneath, and then sans serif, which means without serif, is where you don't have those strokes underneath. And this is one classification of typefaces, what we see. So these are the classifications we've arrived at, but how do we necessarily get here? That's like a big question we did when we consulted our typographer, because they said that the patterns are observed from a series of heuristics where its formal process is unknown and lacks comprehension. And this is evident in PANOS, which is the current industry standard for classifying typefaces based on 10 attributes that inherits these aforementioned historical design processes with downstream discrepancies. And so this is an example of PANOS. So it has, again, like these 10 attributes, and this is for Times New Roman, where you can see the family kind is Latin text, you have the serif type, which is the cove, and all these different elements. And so, again, going back to our typographer, we see that the initial version of the PANOS system was comprised of 7 classification categories that was based on subjective visual parameters. And so really consulting this brief background, well, what happens is that right now, for example, so the Helvetica, it's a type fonts, that's a sans serif, and then there's these serif fonts. They've both been successful to help readers with dyslexia, but then most often it's the sans serif that helps, that said. So typeface legibility varies significantly depending on the reading situation, which is an open question. And this overall leads to questions on the nature of discovery of typeface. And so what we wanted to do in this project was to recenter the creative practitioner based on some of the historical analysis that we've been able to make. In that sense, you have the typographer, you have the AI system, you look into the AI system, and then, well, the typographer is like, yeah, I'm looking into the latent space. So that sort of maps what we're really trying to do of mapping the latent space of digits. So the objectives we have for the work is to expose the typographic latent space of an encoder to represent typeface letter forms separate from those outlined by PANOS. And I'll explain what we really mean by the typographic latent space. Identify the nascent needs of typographers with the integration of AI into the creative domain, and then utilize the technology alongside human-centered AI initiatives, because that's sort of where we have that responsible design element coming in. So our methodology is we use a data set called the TIMNIST. So TIMNIST is a data set that was developed by AI Skunkworks, which is where the project was consisting. So if you're familiar with the MNIST data set, it has all the numbers from 0 to 9, so all the 10 digits. But what we did here is like we classified them for all the 2,900 font types that there are. And so an example that we have here is like you have these numbers, but based on the different font types. So the number 6 here is in a different font than the number 6 here. So this is a big data set of nearly like 30,000 examples, and it's available on our GitHub. So we used this data set, and then we trained a disentangled beta VAE. We had different variations of hyperparameters. Our dimension for our latent space was 16, in line with the MNIST data set. And then we manipulated the beta value, which was one of the reasons we used this architecture. And then from there, what we wanted to do was sample the latent space. So we used both a Gaussian mixed model and overall distribution to sample the latent space, look inside what the model was actually learning, and then use that exposure to take it back to the typographer so they can see how that model was really trying to understand the different ways in which the font types came to be. So they can use that to identify new font types in which they say, okay, the model is learning these attributes within the latent space, and then we'll also see how those are coming to be. So we can see these different attributes that maybe PANOS was not outlining, and those 10 that I mentioned earlier on, or those that they can see are ways in which they can identify novel font types. So we're not necessarily looking at the end product of what the model was able to learn, but really break it in half, you open it with a microscope and say, this is what the latent space is showing, and this is what we want to know as development of different font classifications or different ways of fonts are coming to be. So these are our results. So we sampled the latent space with the Gaussian mixed model. This was the latent space that we saw. So it doesn't really necessarily pick up those deep insights that we wanted to see, but it's funny because when we also use a normal distribution, the distribution was I think because the Gaussian mixed model, I guess, as we saw in the graph earlier, was able to capture it in a sense in the middle ground more than the normal distribution, which seemed to be sparse. So it didn't learn as well in the normal distribution. And then reconstructing on the test set, this is just to see how well our model was doing. So the results that we have here, I'll also go into it after this, but the discussion is that, well, we're really looking at the quality of our model and recreating the font type. So we see the latent space. I wasn't able to necessarily grasp these little nuanced attributes, because at the end, like if you saw the examples I proposed earlier, it's almost like the difference between a tiny stroke of a serif and that without a serif. And then we also saw that some numbers are more than others, such as like a 2 or an 8. But what we really wanted to understand is what attributes can be picked up from the test set. So what attributes are we trying to see that the latent space was able to pick up? From the idea and the project that we proposed to where we are now, I would say this is a work in progress to a certain regard, because we're still trying to develop our model to a greater extent. And as you can see, the fidelity in the test set wasn't there as much as well. But really presenting this analysis overall for typographers to investigate current heuristics, identify novel font types, attribute distinctions in the latent space of fonts, and really to empower their creative practice given the burgeoning integration of AI with the creative domain. And so bringing that back to the initial comic picture that I had, then you have, okay, so the AI is like, okay, you are in my workflow. The typographer feels much more empowered. The creative designer says, well, that's responsible design. And then other creative domains will want to follow. So that's sort of the workflow of the work that we have here. And then also going forward, extending towards alphabets and non-Latin typefaces. And then as the work was in the nature of a pictorial that we submitted, this was the paper, our final paper that we put forth. And perhaps I'll give you like 3 seconds. I have like 10 seconds before I'm 10 minutes. So I don't know if anyone can pick up some things in the background. So when I wrote it, I just had like typography like as the main letters of each one, because I was like, it's a pictorial, but this also has a bit of words, but typography is an art, which is what we're proposing in this pictorial. So it's an artistic element of typeface in itself. So yeah, thank you so much. That's me if you want to connect and speak further. And then this is our data set that's available on GitHub for anyone to use.
Great. Thank you, Alight. Excellent kickoff for our second session. And definitely the theme of responsibility is something that's going to come up again and again this afternoon or this morning, depending on where you are. So moving right along, as I said, questions we're going to keep for the end of the session. So definitely write those down in your notebooks and in the chat. We're going to move right along with our next project from Tobias Bongott, Marching the Manifold. So I think you have permissions for screen sharing. Hopefully it will work out.
I'm just sharing my screen.
Excellent.
I think that's the wrong one. Let me just stop share and share again with the correct screen, I hope. Screen 2, share. Yes. Now we are at the presentation. I hope you can hear me. And let me stop this. So,
perfect.
Okay, I'm just starting. Sorry.
No problem.
Thanks for having me. I want to use the next 10 minutes to tell you about my bachelor thesis, Marching the Manifold, which focuses on visualizing semantic relationships in CLIP's latent space. Just very shortly to my person, my name is Tobias Bongertz, and I am a recent graduate of Bielefeld University of Applied Sciences in Germany, where I studied digital media and experiment. For my thesis, I asked the question on how visualization and interaction design may help demystify the inner workings of AI models, especially for non-technical audiences and practitioners in the design field. And yeah, well, now let me show you the finished product. And after that, we can go into the technical intricacies. This is a web interface that runs on Vite with React and 3.js. Each white point you can see is one learned word concept, which means I fed over 235,000 words into clip L, which is the text encoder. And however, at the time of writing my thesis, the most interesting part for me was actually to learn what is in between these word concepts and if it's possible to visualize that. And of course, that's possible. You can just feed these vector embeddings from the ClipL text encoder into a diffusion model and generate the images. So every blue pathway you can see connects two words together, of course, with sub-steps. And each step on the way is visualized with an image of the diffusion model. So I pre-generated 59 pathways with close to 9,000 images. And you can scroll through these pathways and select them. We can just maybe go from milk to coffee. And there's also a physical controller for the audience to interact with. And you may see this in your or on my webcam. This is just a 3D printed own design, which has a rotary encoder and some small Raspberry Pi in it, and some LEDs. Yeah, so this is an image of the exhibition with the projection of the web interface on the wall and the controller in front of it. So now I want to take you back to the first few weeks of my bachelor thesis, which mostly encompassed research on the topic of just how does AI actually work. And the first thing I did was to look for words I could feed into something that would then generate images for me. So I found the NLTK corpus, which is an open source repository for students just to learn machine learning, which well encompasses 335,000 words, which I then well fed into clipL, which is the text encoder I used. And later, when I had the embeddings, I fed these embeddings into FluxDev because, at least in my opinion, it's still one of the frontier models when it comes to image diffusion. Yeah, and after I had all these requirements, I did the first tests with linear interpolations. And as you can see, this can work very well. But the problem is that these straight path lines or pathways not necessarily follow the structure of the semantic manifold in the latent space. And that also means that these pathways not always generate some semantically valuable images. To be honest, for me as a designer, these images are the most exciting or most interesting images because they kind of represent concepts that sometimes are very hard to describe with human language. And this is, at least for me, that's very intriguing. So what I was more interested in, at least for the bachelor thesis, was how I could make an actual traversion on this semantic manifold. And this turned out to be very hard, at least for 3 months' time, and no serious background in mathematics. So I had to reorient myself and take notice on how pathfinding is done in the, of course, real world, which is, in a nutshell, just connect the nearest points and find me the most optimal way where I wanted to go to. So I went one step further and actually built a tool in Python which generates optimal pathways between the starting point and the endpoint in the latent space. And a big help for me was the FICE library from Facebook, which just contains numerous algorithms for similarity search in the high-dimensional latent space. And the next step was to incorporate a beam search algorithm with scoring. So each step would only retain the 50 highest scoring pathways and start from there, again adding points via nearest neighbor search, and again only retain the 50 highest scoring pathways. At last, I was left with an output of the best 10 pathways regarding how well they progress towards the target and how well the path aligns towards the target. And so I ended with something that, of course, doesn't look like that, but more like that, where the intermediate embeddings serve as waypoints, and the linear pathways in between are just interpolations. This, I guess, worked fine for me, as I never drifted too far away from where I wanted to be. So all the images I did generate actually did work. So let me wrap up my presentation with the last 2 slides to summarize everything again. So the words taken from the NLTK corpus were fed into the text encoder clip L. And from there, I use UMAP to down project clips 768 dimensions down to 3. And from there, I fed the embeddings into the web interface. And I also did incorporate the tool, of course, with FICE and the beam search algorithms to generate the needed pathways. And these pathways were then fed into Flux and also into UMAP to then also show in the web interface. And I hope that this web interface can spark a little bit of interest and also the understanding of maybe how the latent space kind of works. And the physical interface I showed earlier was just to reduce some cognitive load. So I don't want it, the people to learn a new controller and also learn new concepts in the latent space. And I also tried this celestial theme to improve also on this spatial understanding of the latent space. And if I would do it again, I would incorporate more data, which would result in a better dimensional reduction. And that's it from me. Thank you.
Thank you, Tobias. Also, really fascinating work. This discussion of embeddings in latent space is also something that we'll be touching on during our Q&A. But as I mentioned, we are moving on a tight schedule because I know everybody in Brazil hasn't had lunch yet. So we are going to move right along to our next panelist. Ludovica Sheroff, skip inject in expanding control of diffusion models, leveraging the models themselves.
All right, so hello, I hope everyone can hear me. Now I was Googling you because the presentation was great and I loved it. So I'll be sharing my screen. Unfortunately, I didn't make it home on time, so I'm at a Starbucks cafe, so the audio might be terrible. But today I'll be presenting a work that I called Skip Inject, which was kind of recently presented at CVPR in a workshop on kind of creative content generation and editing. And basically what this paper started with was that, as we all know from kind of 2023, the generation of images became incredible. We could create such an expressiveness of content, but the ability to condition and to control what we were getting kind of remained limited for quite some time. So the first kind of broad question that this was targeting is, once an image is generated, how do we edit it instead of kind of starting from zero? Because if we just change the prompt, we would just get another different image, even if we keep the noise the same. And the second one is, how can we do this through leveraging the representations that these models are creating? So how do we understand what representations these models are creating, and how do we use them for editing? So just kind of a little bit of a background. So diffusion models, which I assume everybody's familiar with, they work as a kind of iterative denoising model where we start from a noise here on the left, and through several predictions, we predict how to remove the noise from these models. And one of the most important kind of elements of this is whatever the backbone prediction model that our diffusion model has, we always have a cross attention we always have this kind of cross attention, which mixes the text information with the image information and allows us to kind of reroute towards the desired image. So in editing domain, this is what has been used so far the most. So it's a way to kind of keep the structure of the image and changing the prompt. And this kind of works very well, but it's very strict on the structure of the original image. So my question was, what if we, on the other side, look at the skip connections? So early stable diffusion models all relied on an architecture called the UNet. And the UNet is kind of famous for this long residual connections. So this means that the information in the network doesn't only flow from the encoder to the decoder, but also has kind of lots of different layers that pass the information over to the decoder. This is very handy to kind of pass very structural information to the network, and this was the hypothesis of this field. So what I did is I started kind of two parallel denoising models. So one is, for example, with injection image A, and the other one is with an original image B. And this was, for example, like a zebra on the moon and an elephant in the savannah. And what I did is at every different experiment, I changed one layer of the skip connection. So here I only changed what we have in the what's called the H space, and we can see that from the original image nothing changes. Here again, I also only changed these three layers, here only these, and so on. And what we can see very clearly is that we have this one space kind of midway through the network where the information is merged. So I went on to separate the three layers. So we have here L4, L5, and L6. And we see that most of the information flows through this L4, but a mixture of L4 and L5 somewhat passes the whole structure of image A, but it changes the texture of the image B and also the color scheme. So in other experiments, we can see that this is also bad. Then what I tried is, okay, let's change where we start injecting this new image. Let's see if this has any implication. And what I found is that kind of weirdly enough, if you wait for the injection, what you're doing is you're determining the background. And not only passing exactly this background, but passing only the concept of the background of the other image. So here we see a moon, which was in the prompt of the original image, which reappears, but in a different form. Lastly, I also saw that there are several ways that we can modulate how much we are shifting from one image to the other, maybe in similar ways to the interpolation that we associate. Well, since this was published in a computer science journal, we had to prove that it was state of the art. So the bottom corner on the right would be the most performative, and we can see these models almost always achieve the best performance. And here I just put like a quick example of this. So with an original image and the prompt of a silver robot walking on the moon, we can see that ours is the only one that actually fully contains the same position, but actually shifts to being a robot and not kind of this weird hybrid that the other ones have. And since we found that this is disentangled, we can also do the other way around, so not passing the content, but passing the style. And in this case, we can say we have this original image, and the question is painting of cloud. And okay, this is kind of what the style requirements in computer science are. So I didn't choose the prompt, but we can see that this is kind of the only one training free. This, for example, abstract text-to-pixel is not training free. That achieves the same kind of color chromatics and doesn't oversaturate the image. So as kind of like a broad view on this, I believe we have kind of shifted paradigms on how we are achieving control of our creativity. And I would say that this work kind of helps us towards the paradigm of mixing representations. So taking something that can be generated and mixing it and seeing if we get something interesting out of this. So I tried it with some creative community elements, and one is, for example, to use images generated by Midjourney and kind of be able to transfer their style on Stable Diffusion or open source libraries. And this is where you can see on the top and on the bottom. I also tried to use style prompts that were released by the community and see how you can use them to edit your images. And I think it's kind of like a very quick and easy tool that can be used. So in conclusion, I think the good side of this is leveraging already what is being learned by the models and doesn't require any training, so it doesn't use any extra energy consumption. And it does allow greater flexibility in this kind of mixing expressiveness. But at the same time, it doesn't fix any of the problems of the original model. As for the artistic property infringement, although this is using Stable Diffusion 2, which is the one that's supposedly the least artistic property infringing one, and it does propagate. So maybe as a closing question, I was wondering what is the desired level of interaction with these models and how do you think? Because I'm not in this kind of interaction community, and I think it's a very interesting question for computer science at the moment. Thank you so much.
Great, thank you, Ludovica. Yeah, definitely the discussion here, where does interaction end and where does computer science begin, is a very, very long and problematic discussion. But I can say, as a UX person, maybe in the Q&A later. We're not getting into that right now. So as I said, save your questions for later. We'll be coming back to all of these really, really interesting, totally cross-pollinated concepts at the end. But we're going to move along to our next presentation from Hussein Özçınar, Evolution and Transformation of the Computational Design Ecosystem.
Hello.
Good afternoon or good morning.
Good afternoon for Turkey and good morning to you.
Well, almost good evening to Turkey.
Yes, it's 5 p.m. in Turkey.
Fantastic. Well, we can see your presentation, so whenever you're ready, you have the floor.
Can you see it's exactly? Is it okay?
We can see it. It looks like it might be a little distorted. It's got a slight aspect ratio squeeze on my screen, but it's definitely readable. I don't know how it is for everyone else.
Okay,
But it's totally readable, yes.
Okay, if it's okay, I can start.
Yeah, go for it.
Hello again, and thanks for listening and having me, and greetings from Turkey also. As you know, computational design is undergoing the greatest transformation, maybe in the history, with artificial intelligence. However, we lack a systematic map of this change, systematic literature map of this change. And in fact, this study aims to mapping this field as a scientific discipline. We aim to provide evidence-based answer. We analyzed 25 years of the field's accumulated knowledge, and we gathered more than 12,550 publications. Our goal was to create the first comprehensive map that illuminates our field's evolution and future trajectory. The field emerged from parametric architecture in the early 2000s, and as Greg Lyons said, animate form introduced algorithmic building design, while John Media's design by numbers showed the artist how code could become creative medium. These weren't just new tools, but new ways of thinking about creativity. What started as geometric experimentation expanded to include optimization algorithms, then integrated with digital fabrication technologies. Today, computational design spans multiple domains, like architecture, which uses parametric and generative design, engineering, uses digital fabrication and optimization methods, arts embraces creative coding, and AI-assisted creation, and computer science develops machine learning for creativity also. Four research questions drive this investigation, each revealing different dimensions of computational design transformation. First, how has computational design evolved thematically over 25 years? This reveals whether we are seeing gradual development or sudden paradigm shifts. Secondly, what patterns of interdisciplinary knowledge migration exist? This question explores how computational design operates as a bridge between fields, revealing systematic pathways rather than random knowledge flow. And third, how do geographical factors influence research focus? And what are the implications of AI-driven transformation? And now we are at the methodology section. Building a comprehensive map required solving a fundamental challenge and systematically collecting required data. To do that, we get it from various disciplines, for example, computer science conferences, architecture journals, art exhibitions, and engineering publications also. Our solutions, we firstly analyzed major review articles from the past 15 years across conferences like ICCC and the other famous conferences and some journals also. Then we revealed three critical keyword dimensions. First dimension was computational process. The second one is creative applications, and the last one is emerging AI or machine learning technologies. And keywords were determined along three axes, which I said before. We used the Scopus as a database, and we gathered more than 17,000 records and filtered the dataset. For example, if the paper doesn't have abstract or doesn't have any publication date, we are eliminate these publications, also duplicates eliminated, and etc. And as a result, 12,550 high quality publications from 2000 and 2024 were used as the dataset of this study. As text corpus, we merged the titles and abstract of these studies. Traditional topic modeling, or LDA, assumes that words keeps their meaning along with the time or different publication outlets. For example, generative design means the same thing in 2005 and 2023 in computer science journals and art magazines, but computational design's meaning has evolved dramatically between that time and between these publication outlets in different disciplines. Structural topic modeling solves this problem elegantly, allowing the same words to mean different things in different contexts. Generative design in 2005 architecture papers connects to parametric modeling, while in 2023 AI papers relates it to the neural networks. We tested configurations from 5 to 25 topics using three criteria: semantic coherence, which means do topic words appear together in real documents; exclusivity, how distinctive is each topic; and perplexity, which is predictive power of the model. 15 topics emerged as optimal, granular enough for meaningful distinctions, and broad enough for practical interpretation. Here we see the charts of both coherence and perplexity scores. As a result, we chose 15 topic model. This diagnostic chart reveals the mathematical precision behind our topic selection. The left graph shows semantic coherence. Higher values mean topic words actually appear together in documents. And the right graph shows perplexity. Lower values indicate better predictive power, meaning our model captures genuine patterns rather than noise. Both metrics converge around 15 topics. Below 15, we lose important distinctions. Different research areas get inappropriately lumped together. So we chose 15 topics. These 15 topics represented computational design's DNA, empirically discovered them spanning theoretical foundations to practical applications. The prevalence hierarchy tells a story which architectural generative design leads at 14.3%, reflecting parametric foundations, but AI-based design has surged to second at 11.7%, research that barely existed when our analysis began. Manufacturing and fabrication at 9.8% shows digital production centrality. What is fascinating in this is that topics span the complete spectrum of research. At one end, we have purely theoretical work on computational creativity theory, and at the other hand, we have highly practical manufacturing and fabrication research. And everything crosses traditional disciplinary boundaries. Architecture meets computer science, arts meets engineering, and etc. We are seeing a post-disciplinary field emerge also. Creative coding doesn't just use computer science tool, it builds programmatic with artistic expressions. User experience design isn't just interface design, it brings psychological principles directly into algorithmic development. And urban spatial design takes computational methods and applies them to entire cities. Computational design, in fact, didn't evolve gradually. It underwent a sudden, dramatic transformation with a clear inflection point. As a visual inspection, it seems 2017. The AI revolution in numbers, AI-based design exploded from 5.2% to 18.7%, a 250% increase, which is nearly 2.5 times. Creative coding doubled from 4.9% to 12.3%. Data-driven design nearly tripled from 3.1% to 8.9%. Traditional approach declined sharply. Architectural generative design fell from 18.5% to 11.4%, and optimization and simulation dropped 40%. 2017 marks the critical inflection point when TensorFlow became user-friendly, GANs produced convincing images, and cloud computing made AI accessible without supercomputers. Our STM analysis makes these migration patterns visible for the first time by tracking how topic prevalence changes across both time and disciplines simultaneously. Because we included disciplinary classification as a covariate, we can measure exactly when specific topics become more prominent in certain fields versus others. This qualitative approach reveals systematic knowledge flows that would be impossible to detect through traditional literature reviews. As a result of this analysis, three major pathways emerged: AI from computer science to design, beginning around 2015, but accelerating dramatically after 2017, represent the most significant contemporary transition. Geographical patterns reflect deep cultural values, institutional strengths, and industry ecosystems shaping how different societies approach computational creativity. Nordic leadership in human-centered design, Sweden, Finland, Denmark dominate sound and music production and user experience design, building on experimental electronic music traditions and social democratic values emphasizing human welfare. At the same time, East Asian countries focus on visual communication dominance. For example, Japan, South Korea excel in visual design and typography, and games and interactive narrative leveraging sophisticated graphic design. North American technology intensity, USA, Canada leads AI-based design, optimization, data-driven design, and reflecting tech company concentration and world-class computer science programs providing early access to cutting-edge resources. The AI transformation represents fundamental paradigm shift in computational creativity, understanding, contrasting pre and post 2017 approach. We identified 2017 as the critical inflection point through visual analysis of our temporal modeling results, where the spline smoothing showed the steepest acceleration in AI-related topics. This aligns with known technological development when AI tools became mainstream accessible. In the pre-2017 period, designer was as algorithm architect, parametric systems and rule-based generation with clear separation between human creativity and computational execution. Designers controlled all generative aspects, emphasizing optimization and mathematical elegance. In the post-2017 era, designer as creative collaborator time, AI systems as creative partners with emergent behaviors, blurred boundaries between human and machine contributions. Designers guide and create rather than fully control, emphasizing exploration and discovery. And now, emerging challenges and opportunities. New creative possibilities, unprecedented design space exploration, quality control concerns, evaluating AI generative alternatives, skill transformation, which from programming expertise like Python or the other programming language to prompt engineering, AI system creation, and human AI collaboration management. And some other ethical considerations addressing bias in AI systems, questions of authenticity when machines contribute significantly, intellectual property challenge, and etc. In fact, our geographical analysis reveals that certain countries dominate specific research areas, which I summarized before. And these geographical patterns reflect fundamentally different approaches to fostering computational design innovation. Innovation cluster analysis reveals distinct models. Nordic model uses public investment in design research, emphasizing social impact, and East Asian model showcases industry academia collaboration at unprecedented scales. North American model leverages venture capital. And as for the knowledge flow of implications, complementary experts suggest that international collaboration opportunities, different approach to similar problems, create learning opportunities, this study reveals that, and regional gaps indicate potential development areas. Our findings reveal critical directions for navigating AI transformation, reshaping computational design. First, we must preserve human creative agency while leveraging computational capabilities. This isn't about resisting AI adoption. That ship has already sailed. Instead, we need to develop framework that position AI as creative amplification rather than replacement. Think of AI as a sophisticated creative partner. Secondly, we urgently need new evaluation framework for AI-enhanced creative work. Our traditional design critique methods assume we can trace creative decisions back to human intentions. But when AI contributes significantly to outcomes, how do we assess quality, originality, or cultural value? We need entirely new approach for evaluating work that emerges from collaborative process between humans and machines. And one of my last slides.
Okay, Hussein, we are at time, so I'm going to have to ask you to please wrap up in fairness to our other presenters, because we are a little bit behind schedule at the moment. So if you could wrap up.
I'm in the last 3 slides. I'm about to finish. Fostering, first, our analysis showed that knowledge moves between disciplines in systematic ways. We documented 3 specific migration patterns: AI flowing from computer science to design beginning around 2015, but accelerating after 2017, manufacturing knowledge moving from engineering to architecture, and creative coding creating bidirectional exchange between design and arts. And close the end. And our geographical analysis reveals distinct regional constructions in different research and some opportunities for fulfilling these research gaps. Also, this study has some limitations. Maybe I can shortly talk about that, but if we haven't time, these are the limitations you can guess. For example, Scopus database mostly in English. So this study is about English literature which is published in English. And also the STM have some limitations, which is well documented in literature. And thank you very much for listening to me. That's all for me now, for now.
Great, thank you, Hussein. Sorry, I have to moderate sometimes, but yeah, we're going to move right along into our next presentation. Char, hi, good afternoon. Char Stiles is going to be presenting fantasy IDEs. So,
Yes.
hopefully, screen sharing is working on your end.
Yep.
Fantastic.
Here we go. Okay. Hi, everyone. I'm Shar. I am a research assistant at the MIT Media Lab, a master's candidate in the Future Sketches group. And this group works at the intersection of art, technology, and design. Specifically, the kind of background that I brought to this master's program is that I do a practice, what is known as live coding. So live coding it is a performative way of writing code on stage as it live compiles so that the audience can see live electronic music and live visuals being made in front of them. It puts like spontaneity and improvisation back into electronic music because, you know, we've all been at electronic performances and been like, there's no way to tell if they're just like pressing play and then I'm just watching something that's been pre-recorded. And so I've been taking code into places where code really should not go. So like festivals and clubs and different places. So for my specific way of live coding, because it's a whole movement, people have been doing it for like 2 decades and maybe even more. But specifically, my kind of take on it is that I really try to involve the audience into the programs that I have been making. And so I've been really focusing on the interface and the kind of tools that I'm using to live code to engage the audience more. So just a little bit more background before I get into fantasy IDEs is this, I made a interface, I collaborated on an interface with Moondave called Carl, which stands for Code AR Live. And I've been working on iterating performances where the audience can scan a QR code and then see the code, the coded 3D environments live as it's being created. And I can also interface with them by writing to them during the performances via WebSockets. And so yeah, the essential research question I've been thinking about is how can IDEs be more conducive for creative coding? And if you need a refresher, IDE just stands for Integrated Development Environment. It's basically the software that we use to make software. Quickly, live coding, like I said, it's a movement. There is a manifesto. I'm not going to read the whole thing. I'm just going to read the last line because it's relevant to my work. And this manifesto is always a draft and it will always be a draft in the spirit of live coding. But the last line, well, the manifesto kind of goes into about how showing your screens is very important. And the reason is because algorithms are thoughts, chainsaws are tools. That's why algorithms are sometimes harder to notice than chainsaws. So in doing this, thinking about thinking and writing software that writes software, I've been, yeah, basically that's what I've been doing. And a little bit of background of like current creative coding IDEs, I'm sure a lot of you are familiar with, is processing and P5.js are very popular creative coding IDEs. And they inherit from processing and like they're all like inherit from the original IDE processing. And Ben Fry and Casey Rees are quoted by saying that they wanted it to be as engaging as possible. They wanted there to be a big play button so that you know what to do when you see it. And this IDE kind of is an encouraging and expects the user to be newer at coding, that they expect the user to almost be like tentative or afraid, which is very essential and needed for these kinds of environments. But sometimes these can be a little limiting after you kind of get past the first initial kind of fear of coding. Another creative coding IDE is Touch Designer, and Pure Data and all sorts of other like node-based programming languages. And these kinds of languages, I say, they kind of like trick the user into coding. Like, you're not coding, you're node programming. But really, I feel like the nodes after a while kind of get in the way of, like, when I'm using it, at least I want to be able to edit the text. I want to kind of like peel back that layer. Or what a vast majority of graphical creative coders use are tools that were made for software engineers. So this is Visual Studio, and this is just like the vast majority of IDEs out there. Like, so many. Like, these are all different IDEs, but they're all technically, yeah, they all look the same. And so I've been really thinking about how can we reimagine this interface, right? So the interface, for example, like the mouse, is something that's like the closest thing to an extension to ourselves. So I've been thinking about like how you can kind of play with it and make it do things that create whimsy and and kind of be unexpected. This isn't part of the IDE. I just made these different mouse drawing tools to kind of like set the tone, you know. So yeah, I'm just really interested in this kind of playing with the interface, having it be like a sketchbook, and really reimagining its place in our pipeline. So again, this question of how can IDEs be more conducive for creative coding? So here we come to fantasy IDEs. So a major feature of the fantasy IDE is that it's bidirectional visual programming and text programming. So that you can go between what I call them tiles, this tile-based programming, and then you can also edit the code that makes the tiles. And so here I wrote a little script that moves the tiles themselves in the program, because also, given my background as a performer, this is really an important part of this kind of this interface, is having it be this kind of like visual program that kind of makes more sense. You might notice that, yes, I do call them tiles. And this is really just for the pun of it being Char's tiles, because my name is Char Styles. So, so another kind of sketch that I made in the IDE that I have been thinking about is that creative coders have an inherently different relationship to the history of their code, right? So source control. Software engineers are used to Git, which is very very building. It's you're engineering something, you're merging, you're committing, all that. But creative coders are more meandering in a space. And so I thought, like, what if creative coding source control was more like had a soft interface? So taking inspiration from Alvaro Casanelli's Chronos projector, which is on the left, which was a project where you could scrub through videos time using the z-axis and a soft interface. So I took the mouse as your soft interface, and I implemented it so that you could kind of push through different versions of your code in this soft way. Of course, this would only work in the kind of graphical programming I have been doing in the way that I implemented it. I have not like applied, I'm sure there's ways to apply like an AI model to it. I'm going to speed up a little bit. So again, I've been thinking about how can we build more intuitive, responsive, and interfaces for creative code. I've been doing these workshops where I give everyone their own kind of fantasy IDE starter to create a new text editor that fits their needs more. And I started with asking everyone these prompts of what's your current relationship with IDEs? Beyond being a helper, how do you wish your IDE played a role in your development? And then also, like, how do you wish it played in the development process, but could only be changed via text to kind of like bring everyone back down to earth? And I took all the responses and I mapped them out in UMap space, and I have some interesting. I was coming across some interesting different. It's how I kind of explored the responses was this clustering way. And the workshop was about giving everyone like an API key for integrating a LLM into their IDE such that it's not a helper. That was the only constraint I put on everyone. I said, you can't have it write code for you. And instead it should be a creative accomplice. And the reason why I didn't want the AI to be writing code for you is because when you look at brain scans of people using ChatGPT to write essays, your brain is atrophied as you are using ChatGPT as opposed to using your brain by itself. And yeah, we don't want that. And so, okay, so another idea that I've been working with to integrate AI in a way that is not writing code for you is that instead of writing code for me, instead it is linked to the audience via a QR code, and then the audience can ask questions about the code, because otherwise they wouldn't really have an access to this to the code in that way. So it's like adding, it's more additive instead of replacing. And I've been performing with this in different environments. Here's an example of some of the things that happened. So someone did actually end up explaining the, asking for the code, which was really great. It kind of like went way too hard on them, but you know what, we can draw it back. Another sketch is the IDE that always compiles, and the idea with this one is that if the IDE doesn't compile for more than a second, it will compile it for you. And it will replace the text in line. And so it kind of creates this adversarial relationship instead of this helping relationship. And it kind of brings you in places where you don't really expect where to go. I've also been working on a critiquing, like this is a critiquing, I guess, agent. As you write the code, it critiques you instead of, yeah. And because AI is kind of like this averaging mechanism, right? So an LLM is really good at guessing what the most average thing someone would say is. So I'm going to skip through that example. And finally, really, of course, like the visual representation is very important. And so here you can see that I'm going from CPU code to GPU code back to CPU code. So the CPU code is getting the webcam, and then the GPU code is creating this kind of posterization effect and then bringing back to the JavaScript code. Oh yeah, and you guys, oops, okay, that's my timer. So if you might be wondering, what am I using to write all of this? JavaScript. We love JavaScript because being able to share on the web is very important, and having it in conversation with other things is also very important. I've been performing with it around in different spaces. And this is my last slide. Oftentimes when we think about the future of creative coding, we think about programming languages. While that's super fruitful, I also think that there should be room for thinking about the interfaces that we're already existing in. It is a lower hanging fruit almost to get into thinking about almost like this meta-analysis of your process, is to come in from the IDE instead of coming in from making a programming language. And also, I just have so much joy writing code in this way, and I just want to share it. So thank you for listening. And yeah, thank you.
Cool. Thank you, Char. Definitely, I'm not biased, but if I had to choose between JavaScript and Ruby, I would take JavaScript most definitely. But that's a discussion for later. I don't want to start a giant beef here with our Ruby folks. Anyway, I'm sure they have comments to put into the chat. So thanks. We're going to move right along to our next presentation. Federico Pedrosa, Song Scent Scores, Computational Design for Charting Dynamic Emotion in songs with a multimodal circumplex framework. Did I got the title right? Yes. Okay, cool.
Yeah.
So you have the floor.
Hi, everyone. It's nice being here with you. My name is Frederico Pedrosa. I am a professor at Federal University from Minas Gerais at Music School. And I am a member of Mosaic, Music-Oriented Systems for AI and Creativity. It's a pleasure to be here today to present this work. Oh, okay, let's change this. Modeling musical dynamic affective qualities remains a significant challenge because traditional approaches often relies on discrete emotion categories. Besides that, music is not a picture, but much more like a video. So the motivation here is to develop a way to represent and visualize these effective musical qualities specifically valence, ranging from unpleasant to pleasant, and arousal from calm to excite, in a more dynamic manner. To do this, we built upon James Russell's widely cited circumplex model of affect, a well-established dimensional model in psychology. This is a seminal picture from Russell's circumplex model. So, to address this representation of dynamic sentiment in music, we introduce a novel open source toolkit available in both R and Python. It operationalizes Russell circumplex model to analyze songs deriving valence and arousal dimensions multimodally, that is, from both the audio signal and the lyrical content. So let's briefly look at the song scent scores architecture. The process begins with an audio file. For audio analysis, we use contrastive language audio pre-trained. It processes the raw audio and through zero-shot classification, infers the sonic valence and arousal scores. In parallel, we handle the lyric content if lyrics are not provided. Let's move these. Yeah. They move to the next stage. If not, an ASR model, such as OpenAI Whispers, transcribes the text from the audio. From the audio. This lyrical text is then analyzed by an NLI model. Just a second. Like Roberta, which also infers valence and arousal scores for the text. Finally, the audio and the text scores are aggregated and can be visualized on the circumplex plot. So, to assess the methodology here, the toolkit here, we run an experiment where we select 4 songs from diverse genres and languages and use 2 excerpts for each song. 13 human judges with varied academic and musical backgrounds rated each of these 8 excerpts on perceived valence and arousal for both the audio and lyrical content using Likert type scales. Importantly, the interrate reliability interclass correlation coefficient for the average human ratings was excellent, providing us the robust benchmark. Let's move this. The same 8 excerpts were processed then by SoundSync scores. We then compared the human averages with the AI scores using Pearson's correlation. This is the 4 excerpts that we used. The first one is a rap song by a Brazilian group that's called Rationals. Jazz by Nina Simone, My Baby Just Cares For Me. A thrash metal by Sepultura, Brazilian group too. And at least at the end, a samba that's called A Vida Moinho by Cartola. Can you hear the rap?
Nego drama, entre o sucesso e a lama. Dinheiro, problemas, invejas, luxo, fama. Nego drama, cabelo crespo e a pele escura. A ferida, a chaga, a procura da cura. Nego.
So this is 2 songs in Portuguese, in Brazilian Portuguese, and 2 songs in English. 2 songs have a really good correlation index. And the samba wasn't so good with the correlations index in human and AI scores. And interestingly, My Baby Just Cares For Me had negatively correlation index. That is something to study in future. So to demonstrate the dynamic analysis capabilities, we conduct a case study on the full song Negro drama segment into 15-second chunks. These plots show the trajectories for valence at left and arousal at right over time for both audio and text. We can observe moments of convergence and divergence. For instance, in valence around the 90-second mark, text valence becomes highly positive here, while audio valence remains negative. In arousal, the audio maintains a consistently high level, while text arousal fluctuates more, with a notable peak at 300 seconds, corresponding to an intense lyrical moment by MC Mano Brown. Further deepening our dynamic analysis of Negro drama, we estimated a temporal influence network based on beta coefficients from a VAR model. This network shows how the affective states of one stream, audio text, valence or arousal, in a previous chunk predict the state in the current chunk. For example, one of the strongest influences is the text valence in the past, positively predicting text arousal in the future here. We also see autoregressive effects such as audio valence tending to persist over time here. This network modeling allows us to understand the interdependencies in the song's emotional narrative. In conclusion, Songs and Scores offers a promising computational design tool for a rich visualization and enables detailed investigations into music's emotional architecture. Songs and Scores provide a varied AI performance across genres, revealed difficulties in traditional Brazilian music. But enhance the constituent AI models is paramount. The toolkit is open source and available on GitHub. Thank you very much for your attention. I'll be happy to answer any questions.
Great, thank you, Frederico. Super. So, as I mentioned, we will be doing questions at the end. I'm like the broken record this afternoon. So we're going to be moving right along into our second to last presentation of the session. Riccardo Palmieri, Generative AI in Audiovisual Arts, Creative Practices, and Hybrid Authorship. Good afternoon.
Yep, I'm here. Good morning for you. I'm here in Brazil.
Oh, well, good morning. We're covering
good morning.
I think a span of like 12 time zones here in the group this afternoon, or this today.
Almost luncheon time, almost. So I'm sharing my screen. Can you see it?
We can see it. So you have the floor.
Okay, nice. Well, good morning again, everybody, and I'm so glad to be here in this workshop. I'm learning a lot until now with you guys, so thank you so much. So I've tried to be fast in my presentation. I would like to show you a few works that have been developed the last year in my personal production. So my name is Riccardo Palmieri. I have a background in architecture, and I have a master in engineering innovation management from Universidade Federal of ABC in São Paulo. So I'm trying to discuss a bit about generative practice and hybrid authorship. So the main objectives of this paper is investigate the impact of the artificial intelligence on contemporary audiovisual creation. So I introduce you this topic using 3 case studies. Try to establish a dialogue between advanced computational techniques and poetic expression. Try to review how algorithmic creation, guided by aesthetics principles, can foster innovative outcomes in audiovisual narratives, and try to point to a paradigm of expanded authorship, wherein human-machine collaborations becomes a new field of aesthetics and epistemological experimentation. So the context, basically, I will examine 3 works. The first one is experimental short movie called Somos. The second one is a game, an educational simulator called the Carbonia Challenge. And the third one is a video mapping intervention called Pindorain. In the 3 works, I've been extensive using the Conf UI using different using stable diffusion, also using flux. So I'll just pass over those examples to show you. Basically, the workflow that I have in every work that I will show you is basically that I have this first conversation with GPT or any other LLM system, and I have an iteration between me and this system. After I use some complementary tool like GIMP or Inkscape or Figma, something to develop image, I have a small iteration between this process, and then I go to ConfUI, and sometimes I have an extended iteration back into the complementary tools and back to ConfUI to have my final product. The cases I introduce you, the first one is Somos. It's the short film, audiovisual experimental. It's an authorial project. And this project was funded by Paulo Gustavo Lau from Santo André Secretariat of Culture. Basically, the system is like I said before, we have a prompt, iteration between prompt and a reference image input to ConfUI. At the end, I use the topaz denoise to increase my pixels and have my videos prepared to post production and in the edition, right? So this is the basic workflow that I'm using inside ConfUI, where I have an input part when I can insert an image, a reference image or a video, whatever I want. I have my prompt. Also, I use ControlNet to use the depth distance, the 3D depth of the image, and also the CAN system who can trace in the image to generate a new image in my output. This is the kind of result that I have in the ConfUI iteration. Like I have this initial image as reference, and I have this kind of frame as output, like this and this. Here I have a small trailer from the movie. So you can see the stable diffusion working, but taking different movements, camera movements, and I can achieve this kind of resource just inputting in my reference images to get this kind of effect inside my result. And also during the edition, we can do some poetic tricks like these blurs and like that. So just going on to avoid losing my time. I have the next project is the Carbonia Challenge. It's a Fuji Carbonia. It's an educational simulator to explore and learn about carbon dynamics in atmosphere. I produce all the images inside the simulator, most of the images using ConfUI, using the Flux One channel, because we have this as a commercial use, so we decided to use the Flux One channel. Dev is better to results, but Flux One channel is Apache 2.0 license. And well, we are just developing the images of this project. So the workflow, basically, we have the simulator, we want to generate all the images inside the simulators. For that, I use this iteration between prompt in ConfUI. And after that, we generate landscapes for the game, masks for augmented reality application, and some cultural panels for different nations inside the game. So I have this is a basic Flux workflow to generate more masks. In this work of masks, we have just a simple iteration where we can develop lots and lots of results to choose one. And we did it for different 8 nations that we have inside the game. This workflow is more sophisticated because I'm using a reference image. a Kenny processes in ControlNet, and I have my result based on my prompt and my inferred image. This is the process, like I have the reference image, I have the ControlNet working, and my prompt over the ControlNet Kenny. Also, I could produce inside ConfUI Studio this kind of situation where I can have the landscape and I can deteriorize the landscape because it's dynamic inside the game. When you increase the carbon in atmosphere, the nations they decrease the technology, decrease the quality of life, so we can show it like this kind of image. These are the results after treatment, photo image treatment, right? So you have 8 nations with different states of the landscape. And also have these cultural panels who say about each nation. It was developed, all those images are made inside Flux Channel. And the last project is the Pindorain. So it's a project for video mapping. I use ConfUI with Stable Diffusion to produce it. And we did it in Virada Cultural. It's a program that we have once a year in São Paulo City. So the process, basically, we have a reference image. So we develop a manual tracing over this image, like a mask for video mapping. And using this mask and also prompt in GPT and do iteration with that, I can generate multiple versions with different styles of the same architecture. Now, this is the workflow that I have inside ConfUI, where I can put my mask. Here I can see my Kenny, my prompt, and whatever, everything, and my result. Here you can see the results that I have in this situation, and here over position with the mask. So you can see they work only inside the Kenny situation. And this is a bit of iteration to decide which kind of result I wish to my work. Here are some variations of the same work that we had. And I have a small video to show you this, how it works in the practice, in the video map situation. So we have different over positions of architecture over the original architecture of the Pátio do Colégio, who is ancient architecture in São Paulo, like 17th, 16th century architecture. So we can transform the building different ways. It's not new, but it's nice to work with artificial intelligence inside. So as final considerations, I have this integration of generative AI with audiovisual practice. Creates a paradigm of generative co-creations, challenging the traditional divisions between author, tool, and medium. This algorithmic curation emerges as a central artistic practice, mediating intentional composition and unexpected emergent behaviors. This hybrid authorship concept values the joint contribution of algorithmic systems and human curation, overcoming the techno-determinism and anthropocentric dichotomies about authorship. And have as future work this foster this interdisciplinarity ecologies, trying to aggregate multiple agencies like human, algorithmic, cultural, material, interact critically, and reflexively to explore AI expressive potential. And these I have my contact if you want to ask me something after this workshop session. And I think I've finished it. Thank you very much, guys.
Great. Thank you, Ricardo. Excellent. We're definitely going to be talking more about tools and workflows at the end, which is almost there because we have our last, but certainly not least, presentation of session 2. Jose Lopez, computational systems as co-creative agents for visual humor generation.
Hello.
Good afternoon. Hi.
Good afternoon. I'll be presenting my work. Let me see.
All right, you have the floor.
Okay, so my name is José Lopes, and today I'm presenting my work on computational systems as co-creative agents for visual humor generation. I'll probably end up talking more about memes instead of visual humor, actually, but just a disclaimer that we use memes as a medium to achieve visual humor in this work specifically. So I guess I'll start by providing a little bit of context on memes. I think everyone knows what memes are, but I'd like to recall some points that make them such a versatile communication tool. So first of all, memes transcend cultural, geographical, and even language barriers. As you can see in this example, anyone independent of their language can understand what this meme is trying to convey. Next,
Comendo?
usually...
Quem comeu aqui,
Sorry?
cara? Comi aí na lavanderia, mano.
Sorry, I'll make sure that he's muted.
So next, usually it's an artifact that combines text and visuals to convey messages, often in a funny way. So I have this image here as an example that's representing my car that's about to pull something unexpected to ruin my good financial position. Sorry. And lastly, it's a participational media artifact that allows people to express ideas and participate in online communities. I have another example here that I chose because it's more for the research community. I'll leave it for some time for you to see. So, okay, but what's the challenge for creating memes, and why can't just computers make the memes, right? So creating memes actually requires a blend of many knowledge fields such as creativity, cultural awareness, and technical skills. And current research often focuses more on meme generation and on meme classification. But computers alone are not that funny, and neither am I. So we thought, what is the process needed for creating a meme for anyone, even if they can't make jokes, to help them create that meme? What tasks do we need to achieve? So very briefly, we got three processes slash tasks that computers and humans could work together to achieve a visual meme, funny meme. So the first one is meme or visual humor ideation. Then we had the image generation task and the caption generation task. So the solution would be to have computational systems leveraging generative models to facilitate divergent thinking, and having the user responsible for the convergent thinking, basically like brainstorming with a computer. And for that, we tried different interaction approaches. So we ended up creating two systems, one using a conversational approach like ChatGPT, something similar, and the other one uses blocks in a canvas where the user connects different blocks that represent visual humor components. So for the conversational system, we had it divided into sides of the screen. The left side is for ideating the joke, and the right side is for generating the image. So the idea is that the LLM used on the left side of the screen would help the user with the divergent thinking and the caption ideation, while the right side would use an image generation model to create new images. And I have here an example of an interaction using our conversational system. So the first three messages basically are instructions for the users to understand how the system works. And next, the first question that I make, or the first message that I send is, I want to make a meme about presenting an academic paper in a conference. And the system immediately asks for more questions. So this happens because before initiating the system, we provide an instruction prompt where we state what is the system's purpose and how it should behave. So next, system provides suggestions, more suggestions, and I respond. I'll ignore that for now because I'll jump right to the end, where they basically suggest in the middle message, the bigger one in the middle. The system asks, what if the caption says, "My research in a nutshell," and the presentation screen behind them shows something completely unrelated to academia. And I was like a literal nutshell projection. So I sent that message, and the system approved. And the next step was to press that green arrow button on the message for generating an image. So basically, the system sends this message to the LLM and asks it to generate an image description that will be used by the image generation model. And the system provided me with an example for our meme, an image suggested. And lastly, I pressed that generate meme button at the top, which I know it's not the best placement of the button, but it was mostly for testing purposes. And we obtained the final meme. Here in this final window, we can change the caption. We can ask to generate a new caption based on what we had written before and generate a new image. So it's more of a refinement window. But what about the block system, right? So the block system basically leverages also an LLM to provide suggestions and reinforce the divergent thinking. And the user has to connect various blocks that are those components for visual humor ideation to create a meme idea. I have here an example. So here I placed 5 blocks, basically mimicking the same idea of the previous meme, where I wanted to make a meme about presenting an academic paper. So I chose a topic/subject block and wrote that. Then I said that the context would be in a conference, and I would have a character that would be a researcher in the image. I also wrote that I wanted a playful tone of joke, and then I didn't know what type of joke I would like, so I turned to the LLM suggestions, and we can see here on the right the suggestions, and I ended up choosing the sarcastic and humorous. So after that, I asked the system for a caption, so I inputted a caption block and connected to the previous line of thought, so to say. And one of the suggestions that I ended up choosing was presenting my groundbreaking research on procrastination. And I thought that was kind of funny, so I asked for an image with the image block, and then I connected the final meme block that would blend all the previous items and creates the final output. So here I have a better view of both generated memes by both systems. And I have here more examples that were generated. Some of them were by us during testing, and some of them were during a preliminary test with users. I'll leave it for a second for you to see. I can also show it later or send it somewhere for the Discord, or for example. But conclusions. So we basically developed these two systems for co-creative visual humor ideation and generation in the form of memes. And we noticed that both systems humor is dependent on the human agent. So the convergent task is always necessary to set. So the system can provide humorous suggestions, but the human always has to choose the one that they think is the most humorous one. We also noticed during testing with users that the block system supports better exploration of ideas because we can explore multiple ideas at the same time. We can select one block and start a new line of thought parallel to the one existing. While the conversational system is more immersive, allows for users to have a more immersive experience. So the user talks with the system with natural language, and the user ends up being more immersive in the experience. And that's it. Thank you.
Great. Thank you, Jose. And thank you to all of our panelists in panel 2. We've now heard from all 8 of our panelists. So a round of applause virtually for all of our panelists. Panelists, you're not done yet. I would ask all of our 8 panelists to maybe put cameras back on, jump back in, because now the fun part, question and answer period. So without further ado, okay, now it's official. Q&A is happening now. So looks like we have a couple of questions in the chat, first of all. So I'm just going to start with what's in the chat, and then we'll move on from there. So looks like we have a question from Jessica Parente, who asked, hello, great talks. I have 3 questions for a light, small typo in there. First of all, I don't know, you can probably see these in the chat, a light, if you want to follow along with the home version. First question, you mentioned that one of the goals of your project is to create novel type designs. Did you compare the generated glyphs with glyphs from existing fonts? Question mark. Then part 2 of that is, since the work is about typography, I found it more interesting to apply it to lowercase characters. Have you considered this? Why did you choose to focus on numbers instead? And last but not least, part 3, what are your next steps for this project? The generated glyphs are not in vector format. Have you thought about converting them? So I know it's a lot, but you can probably jump in with any one or all 3 of those.
No, this is a great question. I don't see the questions, but thank you for sending it to me. I'll start from the last to the first question. Next steps, I guess, are vector format. Thank you for sharing. We hadn't really thought of it, but that's something that we'll definitely consider. Our next steps that I said was like to expand it beyond the Latin typeface into like different alphabets. And so that was what we were thinking. But the vector format would be a way, because I think we're still working on the fidelity of the images when we're transitioning from vector to other formats. Applying it to lowercase and wide digits, it's because the MNIST dataset is very popular in terms of like image recognition. It's like the day one like database that you'd use to train many things. So using like a typography MNIST felt like a good way to sort of have good comparisons and benchmarks as we're going forward. So that's why we create that data set. And this data set has also been, but the group has been working with it prior to this project. So it's something that we have available as part of like the larger scope of what AI Skunk Works does. And your first question is if we compared it to existing glyphs. We hadn't, because we were still trying to navigate the latent space and then take that to the typographer to see what they say. And so that was sort of like the step in which we were trying to analyze, okay, is this something that you'd find useful in the way you would want to explore different novel font types? And I guess in that regard, the aim of that is so we can sort of give typographers like a way of understanding how font types emerge as a way of sort of working with their creative design process. So I hope that answers your question. Or your questions. And then I also forgot to say when I was presenting, this is part not related to this project, but also that we have a paper in the main conference called Mosaic. So kind of in the sense of like trying to really understand different ways of designing this, having the creative designer and computational systems work together. And then on the paper session 1 for co-creativity, my advisor will be chairing that session, and he'll also be talking about, for those in person, he'll also be talking about a focus group that we plan on running on Tuesday. So if you're interested more about works in a similar way, Casper Hardevold would be there on Tuesday about the focus group for Tuesday, and our paper is on Thursday. Yeah.
Cool. Far out. So yeah, Jessica, hopefully that answered the question. If there's a postscript to that, feel free to put it into the chat. Do we have any other questions from maybe anybody that wants to jump in synchronous from the public, from our audience this afternoon? Now, I know this is a long session, so everyone's probably hurting for caffeine at this point. But since it doesn't look like we have anybody coming in from our audience, I think I'm going to throw one out there. So I'm going to just pose this to the group because across all of your works, we've seen a bunch of different sort of projects, endeavors today, experimenting with new ways to enable humans that make stuff, human creators. We're not totally replaced by AIs yet. And we've looked at things like different dev environments, latent space mapping, how we deal with control over generative AI, all sorts of different approaches today. I would pose this to all of you. How do you see the relationship between system transparency and user empowerment shaping the future of creative tools? And in what ways must or should interface, feedback, and control shift or be modified or put on a pedestal for the next generation of artists and designers?
Hello, Jason, can you hear me? Jason?
Anyone can jump in. Or I'm just going to, I have a random name generator and I'll just pick on people.
Hello, can you hear me?
This is a problem when you wait for O3. You have to wait for it to actually generate the answer to the question. Yeah, please, jump in.
Yeah, I mean, of course, I'm not an expert in interaction. So this is more coming from how I see the models evolving at the moment. And I think we're going farther and farther away from being able to have an interface on them that is not just text-oriented, So with GANs, we could actually move in the latent space. We saw also with Beta VAE, and we could get this kind of meaningful latent space and then have this kind of interaction which is original and new. And then now we have more and more complex models that have less of a latent space, have less of different controls that are within the models. So it's kind of becoming very high level, the interface, if I'm making sense. And I personally don't really like it, but I wouldn't be able to tell you whether it's a good thing or a bad thing.
Well, I don't know if I like it either. I think we're at this very early point in a lot of this, and I think that was also one of the other themes that we were talking about today is how all of this has shifted. I know Hussein mentioned 2017. He isolated that as sort of this shifting point, and I'm coming from the perspective of generative design, generative art was something that was always this question. Okay, well, how do you build the algorithms, and at what point are things like fitness functions self-determined, or are they determined by the hand of the artist? And I think this also ties in with what you were saying, Char, with this idea of creating an accomplice. And for me, I sort of like to think about, okay, well, where's the difference between accomplice and mastermind? And especially in the context of how we're talking about, how LLMs especially are really trying to sort of push people to actually give them the response that they want as opposed to the response that they should get. So this idea of and this builds on what Ludovica was saying, how this is getting abstracted. Maybe how do we determine what the difference is between an accomplice and a mastermind? Maybe that's the question.
Jason, can you hear me? Hello?
Yeah.
This is Pablo.
Hi, Misha.
Pablo from Campinas. I'm sorry to interrupt. I have to steal the remaining of your audience here because we're going off for lunch. Thank you very much for everything. We have arranged for the... I gather that there's a continuation of the workshop after lunch. Is that correct?
I'm sorry. I'm having some audio issues on my end. Did anyone...
I did. Yes.
Okay.
So there will be a third session. So after lunch in Campinas. So the third session will start at 1:30 in Campinas time. So yeah.
Okay, but we're still okay. Our block runs until 12:30 local time. So
yeah, we can still go a bit. So yeah, but Pablo, I think that's what you were saying, right? Confirming that there was
it's just we're trying to coordinate here with the local technical support. So you want to carry on for a while?
We will continue here. Yes.
Okay.
Okay. Yeah, we're in the middle of a Q&A, so we're going to hopefully wrap that up, and then move on to lunch or dinner wherever you might be in the world. So I'm going to put Michelle back on mute. Looks like we lost Char. Ah, there you are. Yeah, we were. Where did we get hung up before the train station announcement? All right, the boundaries between accomplice and mastermind, and what this has to do with intentionality as an artist. What are your thoughts on this?
Okay, so I'm just going to take a quick stab. I think, of course, it's about the intentionality and how we are going to approach it. Something that this was reminding me of was the manifold hypothesis, and how a lot of like the AI work that folks have been kind of converging on, or almost like working together to discover something together. And so I really think that instead of AI kind of doing things for us, instead it's like, actually, to quote Jensen Huang, he says that kids shouldn't learn how to code anymore. We're going to have AI to do that. But I think that instead AI is going to just help us learn the deeper levels of this kind of shared goal faster.
Well, this is also sort of a question that I've been dealing with based on that, because this whole sort of idea of what are we teaching kids? This was also something Jack Ma from Alibaba also sort of went off on this sort of tangent a few years ago before he sort of disappeared, and he was talking about, okay, well, this thing, oh yeah, well, we should focus on teaching kids things like music and fine arts, because that's stuff that humans can still do. That was like 6 years ago, and now it's like, okay, well, my dreams of being a pop star or a photo conceptualist, those are all now gone. So what do we actually teach kids? But this is also sort of the question here of getting back to this idea of vibe coding, and maybe this is something I would pitch. Is Hussein's still in the room? I would maybe pitch this to him. This idea of looking at creative coding and what creative coding means in this sort of new strange space of vibe coding that's been sprung upon us. We can open this up to others if Hussein is not with us.
I can answer a little bit.
Yeah, jump in.
Okay. Yeah, I think I just want to answer the question when you said, so what do we actually teach kids? So right now I'm designing a class. I'm taking a class on designing a class. And the class is about like analog. It's like tentatively titled that Dare to Go Analog with regard to creativity. But the whole class is sort of like trying to understand creativity from that practice of like introducing from the bare bones of like Mark Bowden, the different frameworks of creativity, and introducing that framework to like artists and students who are taking that class, and then having them write a creative statement, introduce like tech-based art to different formats, and then revise their creative statements, and then also sort of like make a piece in response to that creative statement. So that's sort of like the way in which one approach can be like, you can still have that bare bone of creativity, but then those different formats would change. And if you feel like you're still have that pedagogical outlook of creativity from, I guess, a way of them understanding it, then the utility of the technology would go downstream in that light. So that's just one thing when he said in terms of like how creativity can go going forward.
Does anyone? No, I think it's super. Does anyone else want to sort of latch onto that? No, it sounds like this is the hardest part about doing the second one in the afternoon is I have to sometimes pull teeth out there. But it looks like we've got 9 minutes towards the end, so I would maybe wrap this up with sort of another open question for everybody, because I can't really actually see who's here and who's not. But we've been talking about a lot of things like for instance, real-time improvisation, embodiment, feedback, things that are traditionally the purview of humans. Again, everything from generating music to like humor. Like these were things that specifically were human domains. Obviously, we're dealing with all of these sort of let's say prompting systems through sort of a language space, and this idea of, okay, well, we're speaking with things that we don't actually have a way of articulating from an evolutionary standpoint how we deal with machines that speak. Traditionally, speech was also one of these domains that was exclusively human, and out of that sometimes there are these surprises that pop up out of this. So I maybe pitch this to everyone. What technical or conceptual breakthroughs have you folks experienced in your work by allowing for improvisation and also also serendipity and sort of rolling with the punches. And how has this been different in this sort of weird, super accelerated post AI age that we're in now? How does this compare to like creative process, traditional creative process for you guys?
I can kind of take a quick stab
Yeah,
at it.
please jump in.
So whenever I think of using AI, I mentioned this very briefly in my presentation, but I wanted to emphasize that it is an averaging mechanism. So it's this way of finding what the most average kind of take would be on the thing that you're doing, because that's what it's really good at. So it's really good at like, you know, the kind of like 90% of the basis of a project, right? But it's always the 10%, right? It's like the same way that bananas and humans share like something like 90% of the same DNA, and it's like the last 10% that really separates
It's like
us.
Pareto's law, yeah.
Yeah, exactly. And so I always think about like whenever AI is in my workflow, it's like how would if I had someone who would just be guarantee give me the most average response, like how would I incorporate, you know, that basically responder into that workflow? So whether it be for images or for my or like, you know, writing, anything like that. That's the kind of, I guess, filter that I've been applying to myself when I'm working with AI.
Oh, well, this is also, I was thinking about something as you were talking about this that Ludovica was presenting, this idea of disentanglement and how we sort of, and obviously this was a visual process of looking at how we separate out content and style, but how does that work for something like music or humor? I don't know, Jose, how do we separate it? Can you separate content and style in humor? Is that something that's doable, or do you think it's not even a relevant goal? I don't know.
So, sorry, can you repeat? I think I
Do
didn't.
you see a way when you're creating machines that create humor or emulate what humans recognize as humor? Do you see also like the ability to separate out content and style, or in the context of humor, are content and style irrevocably linked? That was the adverb I was looking for.
No, I think the content is so the content of the joke is one thing. It's like the theme of the joke. I think when I created that block system, we currently are refining it and basically exploring kind of that idea. So there are the content, and then there's the humor mechanism. So the way you achieve the humorous part is different or independent that then of the content that is in the joke. I don't know if that
Oh, no,
makes
I'm imagining, you know, something, you know, sort of along the lines of like, you know, Henny Youngman being done by Lenny Bruce or something. This idea of, you know, how do we apply these sort of concepts, like the idea of style transfer? How would that be applied to, you know, something like humor or one of these other domains, you know, like theater or something else? But yeah, no, definitely really, really interesting discussions this afternoon. I would say this is the last call for anybody in the public who wants to jump in. No? Okay, well, before we wrap this up and say thank you to everyone, does anyone from the panel have last words they'd like to share?
If no
No?
one wants to say anything, I can say something.
Yeah, please. Sure, jump in.
Thank you all for coming. We will do a short break now. So basically, we got interrupted by people in Brazil. What they were saying is that everyone needed to leave for lunch, but because we are online, we don't need food, do we? So they just went for lunch. And so we will reconvene in 1 hour, okay? Wherever you are, in 1 hour, we can meet here, maybe a bit earlier, like a quarter to 1/2 past something, wherever you are. And for those that are still there with us, I hope that you are enjoying. And I would like to thank a special kind of people that I forgot in the beginning, which is the program committee. We had a very long program committee that was the reason why this is happening. If it was not the program committee members reviewing papers and assisting, and also the organizers who accepted our invitation, this wouldn't be happening. So see you in 45 minutes, maybe, Jason.
Yeah, I would say let's stick to the hour, because we didn't have a human needs break in this
Okay.
session, and I've been on the screen now for like 14 days. So definitely coffee, water, walking around, looking into the distance, enjoying the air in Brazil if you happen to be down there. So I'd say let's maybe put in an hour, and then we'll come back at 1830 Central Europe, 1730 Portugal, and whatever time to 1330 in Campinas. So one more time, a big round of applause and thank you to all of our panelists. Thanks for putting up with my moderating, and thanks to all of you for some really, really excellent discussions and some great work this afternoon. So I'm done. Go enjoy some beverage of your choice. We'll see you back here in 1 hour.
Amazing moderation, Jason. We will
thank you all.
leave Zoom open, so feel free to stick around, and we'll just leave the room open. Okay, see you in a bit.
Sounds like a plan. Ciao.
Ciao.
Thank you very much. Ciao.
That is it Joanna or Joanna? You can correct me there.
Joanna.
Joanna, okay. In the Scandinavian languages, we also pronounce the J as the more of a Y. But Joanna, if it takes him a moment, a little bit longer to get on, are you okay presenting first?
Yeah. It's okay.
Okay. So we'll give him just a minute more. Okay, there's Pedro. Let's see.
Yeah,
Oh,
I'm sorry.
hi, Pedro. Would
Hello,
you?
can
Yeah, we can hear you now. Do you have a stable connection, or would you prefer for Joanna to go first?
no, yeah, I changed network. I should be fine.
Okay,
If
wonderful. Please,
if it
please
cuts
go ahead.
again,
Yes, of course.
yeah. Okay, all right. So you guys can see my screen, right?
Yes.
Oh, okay, perfect. All right. So hello everyone. I'm Pedro Moraes. I hope you guys had a good lunch break. At least in Brazil we had. So a coffee break or something like this. Today I'm going to talk about how generative design and kind of like territorial strategy can shape together a change in agroecological value in Brazil, Atlantic rainforest, right? This project started in University Coimbra with the mentorship of Sérgio Rebelo, João Cunha, and Thiago Martins, and is now continuing in my original university, that is Federal University of Paraná, with the help of my professor, Ken. Okay, so the context of this project, as I mentioned, is Atlantic rainforest, one of the biggest biodiverse and endangered ecosystems in the world, where it sustains and resides almost 70% of the Brazil's population and 80% of its GDP. One of the most iconic species that we have is the Jussara palm tree, and is used as a case study here from is a strategic shift from the palm hair extraction, which killed the plant, to the fruit harvest that have a lot of food chains and value chains attached to it. You may know it as acai, so you guys may already have tasted it or similar to it. So acai is a different palm tree, but it kind of have the similar shape, right? So the first step of this project was understanding what is the context and what narrative we want to bring into to the emphasis of it. So from the interpretations of Felsing, we wanted to describe as a context reflexive. So that means meaning borrowing and reproducing cultural and geographic features that we have in this context of the Atlantic rainforest and from the Jussara. So you can see right here part of the mood board that inspired the creation of the symbols and the colors that we have. So what are the producers? What are the species that feed from this Jussara? What is the Jussara, which I mentioned is similar to the acai, but is a little bit different. And what is the region that we are talking about, right? The next step was understanding how we wanted those symbols to kind of interact, and we used the DNA category kind of definition that we have from NES, that each symbol can build together different outcomes every time. So kind of like building a recipe or a formula, depending on the volume of each element can bring different outcomes. So the formula that we had is we want to change the color, the combination, the shape transformation, and the repetition of each element. So as you can see right here, we have kind of this representation as a chart. So for a person, you can be too light skin, too dark skin, all they have the same chances to appearing, different from the fruit of the Jussara, where it could be early, mid, or mature, and the birds can be either the gralha azul or the tucano, two different species that we have in the context and on the mood board. The chalk texture aesthetic we used to leverage existing regional initiatives, which are the VRS, kind of like a governmental initiatives that we have that has the same objective of leveraging bioeconomy in the region. So you can see here the reference that we took. VRS has already partnership with our BNB with a similar strategy of leveraging local producers and local hotels or hostels that they have on the region. So you can the formula is similar into how we create the facial features right here and how VRS represents, or at least the birds we try to mimic a little bit. So to create the results, we used a proof of concept generative identity interface where each producer could build their own pattern and own packaging. And to do this, we use the processing in the version of the JS, so the JavaScript version, and the p5.brush library, which I recommend a lot, and I had a lot of fun using it during the project and was very helpful, into four main functions that we have. So the first one is the background fill hatch, where we have the function to fill out the background and start the process of building each circle and symbol. Then we have the texture head that adds a little bit more of contrast and the chalky texture for each element that we have. And last, we have the circle coordinates that build this envelope for both background fill hatch and texture hatch. And then for each symbol and element, we have the special features. So birds had wings, people had their facial features, and the fruits of the Jussara had their stamps, right? So after each generation, we built this platform that, depending on the inputs, we use the formula to build those outputs. So depending on the size of the, and sorry, this is in Portuguese. Depending on the size of the fruit, you can generate different things on the quantity of fruits that you want, or the quantity of branches and the direction of branches. You would generate different outcomes, right? So this project mimics a little bit of how the palm tree represents the fruits, and not represents, but better arranges the fruits using the birds, the persons, and the people and the fruits as kind of the part of the tree, right? Where those producers could change the title and the description for each product into adapting to what they're selling and what are the stories that they want to tell. So as you can see here, right here, multiple interactions of the visual identity using the generator. So we can go from the bigger fruit to the smaller ones, and you can change the density across all of them. The main goal of this project is not building the best or the most optimized software or code to generate the packaging, but rather starting a debate in how this group of producers could mobilize together to build this group and with the strategy of the territory, and one day share this tone of voice and empower them to get the geographic indication that we see in a lot of products, like the wines or the champagne or the Parmesan cheese and other things like that, right? So in this project, the tool is part of the narrative that we want to start in the debate that we want to start towards the empowering of those producers in this bioeconomy, right? One of the outcomes that we had is partnering with one of the cooperatives, Colipa. After sessions, visits, and interviews, we managed to build more packagings and more adapted to their context that we could display in the biggest organic food fair in Latin America, called Natural Tech, and partnership with the VRS, as you can see here in the background, we could already kind of to articulate this program together. So as I mentioned right here, just a final illustration of the project, of the examples of what we want to foster is the transition of the sales of the unpackaged goods to the democratic packaging system that communicates both territorial identity and individuality of each producer. Now this project is aiming to end in 6 months. So what we want to do is to be able to generate all this packaging that's now being artificially built with Photoshop and Illustrator, all within the same platform that is open source and available in any place, right? So yeah, that's it. Thanks for the time, and yeah, thanks. That's it.
I'm trying to figure out again, doing my applauding. Thank you very much. A really wonderful talk. Very inspiring to see this combination of your research, fundamental work, also bridging with the local community. Are there any questions now? We have about 5 minutes now to take questions. If not, I have a couple, so I can also get started. Okay, I'll start with, I have 2 questions. The first is, I was wondering if you could say just a few more words about what the process was like working with, for example, this company that you show at the end, making the brands for making the material for their particular products. I also work a lot with the public and with companies, and it's always when creating different types of generative software, it's there's a balance between coming to them with something that they can play with, and so they can get a sense of what can be used, and then also coming to them with a fresh plate so that they can really say what their needs are. And so you don't want to give them too much because you want to hear from them, but then again, you don't want to show them nothing so that they can't see what possibilities are. And so I'd just like to hear a little bit about your experience with that, and what those interactions were like.
Sure. So in this example, the cooperative Colipa, they have different producers, obviously, as a cooperative, right? And different levels of maturity for each producer, right? So for example, we had one called Sitius Brigitte. They already had their packaging, they already had all of those stamps, like organic food or familiar agriculture together. I'm sorry, I think my connection is kind of stable, but yeah. So they already have a very high level of maturity compared to other producers that we had also engaged together, right? So what we need to do is we use kind of like play with screen printing at first before we jump into like the software or using tablets or laptops. We first had kind of like display with really stamps that we kind of print and send to them. But I have this box right here, now it's empty, but we kind of send them with those boxes and we kind of let them play with the packaging. And then we started the discussion and how would you like to, like, what is missing from this packaging? What do you think do you already have in your packaging, or what stories do you already tell that you think needs to be here, right? So for example, there is a river that they call Rio Sagrado right there, and it's very important to them to tell these stories of the Rio Sagrado, even from like let's say spiritual connection with the river of that community, that they felt that it is very important to them, right? So it's hard for us to kind of, we are being very open to everything we hear, but also conservative in what we apply, right? So it's kind of like what you mentioned about this balance. But yeah, it was different of types of media that we have to first develop to then go into the generative process digitally, which is very funny because screen printing for me, it's also generative, depending on the color that you have, the amount of resources that you have is always different. So it's generative in all medias, right?
Wonderful, thank you. Before I ask my second question, I'll just see if there anyone else? No? Okay. So my second question, I'm sorry, I haven't been able to be here the whole day, so I don't know if it's been brought up or not. But I have been reflecting a lot on my own work because I do a lot of work also in sustainability and trying to use generative AI tools for social good. Oh, my timer's off. And I struggle a lot now with the tension between the carbon impact of generative AI and using generative AI for social good. And part of it comes from sort of intransparency about the impact, the actual carbon impact is of the various tools. But I was wondering if, as you are also reflect about in the beginning about biodiversity, about this also economic and environmental tension, I was wondering if you or your team have reflected at all on the carbon impact of using generative AI tools.
Yeah, this was one of the debates of when we were trying to develop the tools for us to experiment if we wanted to use generative AI to kind of think about alternatives and generate images with ChatGPT, which I think was a trend, right? And one of the goals of also trying to see, trying to kind of go generative without adding AI to the name. I think it's one thing that we can kind of together build open sources tools that doesn't always consume a lot of servers carbon footprint, right? So I think this is one good way of thinking. But in this project, I wouldn't say that it was the biggest concern thinking about carbon footprint, but I think as being a kind of like this generative forum together right here, how we could kind of detach generative from this kind of all server carbon footprint that we always think about once we are discussing generative AI. But yeah.
Maybe I take that as a sign that oops, now it was my turn. Mine went out for a moment there, my connection. Thank you very much, Pedro, for your presentation and for the discussion. Now we will move on to Joanna. Will you prepare your slides now?
Yes. Can you see them?
See the screen. Now we see the slides.
Okay, great. Let me put this here. Sorry. Okay. Hello, my name is Joana Rovira Martins, and I'm here today to present the evolution of Pattern Pursuit, a co-creative system to produce graphic patterns using libraries built on graphic decomposition. The unpredictability of creativity often leads us to search for inspiration, involving us in time-consuming processes and sometimes defining some limits and objectives during the creative process can help structure thinking and the creation of new ideas. In these terms, the process of designing graphic patterns can be viewed as an interesting task, allowing the exploration of infinite and versatile visual solutions within a controlled environment with rigid limits. Additionally, over the years, the creative thinking process of modern designers has become more complex, with a tendency for them to access only digital references. And this behavior promotes a superficial exploration of references because of personalized content algorithms and neglects the inclusion of pre-digital design works. And as we know, cultural awareness is essential for designers because traditional sources can provide valuable insights that can expand solution possibilities. Pattern Pursuit is an existing ideation system that tries to solve this problem by allowing designers to explore pre-digital design works that are explored on a conceptual and visual level, and using its visual elements produce graphic patterns for wrapping paper. But we analyzed this tool and identified some shortcomings, especially regarding the pattern creation modules. So our contribution in this work lies in these modules. However, since we have reused the first three modules of Pattern Pursuit, I will explain how they work in general so that you can better understand the system. So this is Pattern Pursuit System Architecture. It is essentially made up of 5 modules indicated in yellow. We reused the first 3 of these 5 modules. The black boxes represent the results the user interacts with, and the gray boxes refer to the approaches used by the system. Starting with the gallery, users can analyze and get to know Sebastião Rodrigues' work, who was probably the first Portuguese graphic designer to practice his profession full-time as we know it today. And users can explore it semantically through one or more concepts. Using natural language processing and WordNet, the system creates a semantic space around the word given by the user, enabling conceptual search through the works in the gallery using the clip model. And according to the probability of similarity between the image and the semantically selected word, the works are selected to move on to the next page, the selected gallery. Here, users have access to the semantically selected works, and they can choose the ones they consider interesting to explore further. Once the user has chosen the works, we move on to the decomposition module, which is responsible for decomposing the images into visual elements. This is an example of what the composition module does. These elements include typography, regular, irregular shapes, textures, lines, etc. And the last 2 modules in the previous version of Pattern Pursuit consists of 2 similar evolutionary processes for generating graphic units and patterns. Each has 2 agents, an evaluator, the user, and the solution generator, the system. And here lies the main contribution of this work. Although the previous approach effectively helps users develop creative graphic patterns in a collaborative way, it has some shortcomings, particularly regarding the number of parameters that the user can influence, the machine's decision-making power, and the system limited adaptability to the user's needs. We developed this new version of these 2 modules, taking these shortcomings into account, and we also considered another aspect because if we want to develop a more transparent co-creative system, the system needs to know how to contribute and how to explain its changes. And since we are working with graphic design, we decided to base the system contributions on graphic design principles. So we developed these new modules considering different levels of autonomy as a central aspect. We designed the interface to reflect the contributions of two participants on a common creative output. As such, the interface is divided into three areas: the user area, the creative area, common to user and computational agent, and the computational agent area. The user area contains the library and the sketches section in both modules. But in the first tab, in the case of the unit module, includes the previously decomposed elements and information on where the element was taken from. In this case, it includes all previously developed units. The second tab contains the final sketches saved by user throughout the creative process. The common area comprises the canvas where the unit or the pattern is developed, the user tools, so the user can freely manipulate the canvas, and right below, the visualization. This is immediately below the canvas because whenever something changes on the canvas, the visualization updates and reflects how the principles are being worked on in real time. This also sets the rules that define the conceptual space and the user's objectives. So the system will contribute according to these defined values and its relationship with other principles. Finally, the computational agent area contains the contribution and the suggestion section. The contribution section is where the user asks the computer to contribute to one or more principles. And whenever the computer is asked to contribute, it justifies its contributions based on the relationship between the principle to which has contributed and the other principles. Essentially, the modules operate on a communicative basis grounded in design principles. In other words, it receives ingredients, in this case, the graphic elements, the compose or the units, and applies a series of rules through a reward system and generates the unit or in the next module, the pattern. We conducted a test phase with 13 participants to analyze the effectiveness of using design principles as a communicative basis for producing creative patterns. And these are some of the results developed by our users. This new version of Pattern Pursuit demonstrated that including design principles as a tool supports the creative process. And by exploring different processes and task division, the system responds to diverse needs of users. Thank you so much. I hope you have enjoyed it. If you have any questions, please let me know.
Thank you so much. Very interesting. Are there?
I have a question, Joanna.
Yeah. Yes, please go ahead.
So I was thinking, when you were developing this tool, you had an idea to where would you apply these patterns? Would you use it for IDs, for
Yes. The pattern pursuit was developed to being applied initially on wrapping paper. but it can be used by designers to explore and integrate traditional design elements into modern projects. Also, it hides in ideation and pattern creation, which have always been used and are not expected to stop being used. And it can serve as a tool for generating things like outside of the main scope that was in paper, like textiles, wallpapers, or other graphic products, providing a structured yet creative approach to design.
Okay, good. I think you said that, but I didn't hear or I didn't understand. Okay, good.
Sorry.
Thank you. Any other questions? I have one. So I spend a lot of my work looking at both from a psychology perspective and a human AI interaction perspective, understanding the creative process. And I was wondering, so you talked about how, in some of your initial results, that your tool can support the creative process. And I was wondering if in these user studies with the 13 participants, you got a sense of whether or not the tool supported them throughout the whole process. Because, I mean, you start in an idea generation phase, and then you're exploring and then go through a convergent phase. So trying to choose the direction to go in and then iterating and refining on that. And there's been quite a bit of research that shows that different types of generative support can help in different parts of that process. So different phases. So I was wondering if you observed any of that, or if you could reflect on that for us. And then I was also wondering if you were looking quantitatively at people's processes. So looking at their results. So all of the designs that they gathered, and if there were, so if you were looking at, for example, types of people who are refiners. So they pick one idea and then they just refine it throughout, or types of people who jump around a lot. So I guess a more, both questions are really trying to get more at the creative process of the.
I think I stopped hearing. I don't know if it was me.
I think it was on Janet's side.
Oh no,
No, but you're back. You're back.
I'm back. Yes.
You're
Sorry,
back.
did you get any of my question?
Yeah. I hope almost the entire one.
Okay, good.
If I don't respond to anything, you can ask it again. So the purpose of pattern pursuit as a whole was to support the entire creative process, and that's why it take advantage of references and explore it semantically, so conceptually and visually, to try to give some starting point for designers to have an ideation process. But this wasn't the main focus in the, sorry, this wasn't the main focus in this paper. The main focus was try to propose a framework or a process that can support different needs and different levels of autonomy and agency, because the same designer can, doing the same the design task, can be or can need different, can need no, can follow different creative processes. So this is this module can this module allows the user to follow 4 types of creative process. One more on in where the computational agent always takes on creative agency. One that the agency lies more with the user who can choose to follow a completely autonomous process without any help from the system, or an alternate process where the user can divide or organize the tasks according to users' preferences. So I hope I answered your question. I am not sure if
No, that's great. The second part of the question was about whether or not you were or thinking about quantitatively analyzing the results to understand the process. So exactly like if some people were refining over time, or if some people were just really exploring a lot, how many requests, how many generations at the beginning of the process, at the end of the process. So if you had considered that type of quantitative analysis.
No, I didn't make this type of evaluation. I just try to understand if the process the system improved the creative process or support it, but I didn't analyze if they were trying to having a diverse process or converse process. I didn't analyze, but it's a good a good point of view, and I will consider it. Thank you.
Thank you for your wonderful presentation.
Thank you.
Okay, so for our final talk for today, Rita will be presenting. Rita Silva, is that correct?
Yeah, correct.
Thank you. The floor is yours.
Thank you. Okay. Okay, everyone seeing my... Okay. So, my name is Rita Estevinha da Silva, and I'm here to present you Dynamic Idioms, a computational tool for the development of dynamic visual identities. Wait. So, dynamic branding is not a trend, but actually a new paradigm in the branding field. So static brands and logos are becoming more and more obsolete. This, of course, has to do with the shifting towards more dynamic and interactive platforms and mediums, as we all know. And although this is not a new concept, the one increasingly form of visual identity that is being developed are these identities that are system-based. So they rely on the whole design, they rely on the visual language to guarantee brand recognition without needing or without using so much the logo or the static graphic mark. This is, of course, this is happening, of course, due to automation and computational tools that allow the production of much more graphic artifacts with way less effort and with shorter time. Despite all this progress, the discipline is still very anchored in traditional approaches, and design schools are still teaching modernist ways to develop brands, such as symbols, logotypes, and I personally felt this myself. So the question for me was, how do I think dynamic when I was taught static? To address this gap, we created a tool called Dynamic Idioms, a web-based tool that aimed to offer a comprehensive toolkit to people that wanted to become more familiar with this type of visual identities. Sorry. To achieve this, we based our tool in the taxonomy developed by Tiago Martins, João Cunha, João Bicar, and Penosal Machado. We implemented the variation mechanisms that they proposed. And although they seem quite simple, it's their combination that allows high degrees of dynamism. So users then can apply these variation mechanisms to their own elements that are uploaded as SVGs. And the tool also allows the preview on different formats because, of course, we are working in the realm of visual identities, so we need to test it for different outputs. Now I'm going to show you a demo. So users upload their SVGs. They apply variation mechanisms to each one individually. Variation mechanisms work through sliders, so the user defines the range in which it will vary. The button Give Me Dynamism gets these values that were defined and randomizes all of them. So in each click, it gives different outputs. Users can save to the gallery their favorite results, and then within the gallery, they can check the visual language and the identity they're creating as a whole, as we're seeing here. Then the users can export and apply these results to their own brands. Okay. So now I'm going to show you other results that we developed, some more simple, some more complex. This one is a square that is rotated, scaled, and then repeated. This one changes the position of each letter and they vary their rotation. The tool also allows the generation of patterns, dynamic patterns. Here is an example that we use to apply to a fictional art festival identity. Sorry. Here we generate the visuals and then we apply the typography in Adobe Illustrator. So for these results that I'm going to show you next, this inclusive, we asked the users to answer to ChatGPT briefings. To this case was a tech company, and they used their own graphic elements and they applied their own variation mechanisms to answer those briefings. This one was for a kids bookshop. And the last one for a coffee brand. So to conclude, as seen from the results, the tool enables coherent visual systems, and also it allows many different results because it is based on user-given elements. It helps users to understand the methodologies for achieving dynamism in a playful and engaging way, which was the main goal of the tool. And it showcases the potentialities of automation in the design process, which is also a new trend and the future of design. We found out that because it is very easy to play and delete and experiment, it can work as a creative supporter because this experimentation leads to unexpected results. and sometimes some better than other, but yeah. So if you want to try out the tool, here's the link. I know it's not the best link, but this is what we get. And yeah, that's it. If you have any questions, feel free to ask me.
Wonderful. Thank you so much, Rita.
Thank you.
I will give a moment for people to collect thoughts for questions. You have them, feel free to just jump in. If not, I can also get us started again. Okay, I'll start then. I was wondering a little bit about when you were showing off these use cases of the brands, how much time you spent. So is it something that you sent off to a particular person or company, organization, had them work with it, or would you sit and work with them together, or was it in this particular case more of experiment, more of an initial study where you were working to create them? So maybe you could say a little bit more about that process, and then about how ultimately, if you would think of this as a tool for other people to use without any intervention from you, or if there would be some type of collaboration.
Okay. So these results were developed by users that are designers.
Yeah.
So we did not test it with people that are not familiar with the graphic design, or they are not. We did not test with those people. But I think this tool can work as a without the need of another person. So I think, let me just think of the word. You can use it individually. But you have to have a purpose, because you have to decide which elements you want to put on the tool. So that's your sorry, I received a message.
So would you imagine that it's always going to be a designer on the other side, or someone with a certain level of design experience?
Yeah, I think so, because I believe, and our aim was to make a tool that is more an educational tool than a tool for the real context of brands. So it teaches how to develop dynamic identities, how to apply variation mechanisms, how they can work together, how their combination results in different outputs. But I would not say that it works for real life contexts.
Wonderful. Thank you for that clarification.
I received another message in the chat. Not sure.
Yeah, there
Oh
is.
yes, Steve wrote, I'll read the question. I'm wondering if you could elaborate on some of the potential pitfalls and disadvantages of using a tool like this.
I don't really know what a pitfall is.
Problems like challenges or disadvantages. So maybe traps that people would get stuck in, or not positive things about something like this.
I mean, in the sense that this is to be used as an educational tool, I don't see why pitfalls and disadvantages would happen. So, not sure if this is
No problem.
the right answer. Or maybe if Stig is thinking about something, he could share. Okay.
I'll take that as a no. So are there any other questions? Then let's thank our speakers one more time. It's really a pleasure. Oh, Steve says, sorry, I can't go on audio now. We understand. It's if you're in my time zone, it's dinner time and kids are running around, so it happens. But thank you so much, everyone, for bearing with us in the last session. I'm really happy that I could be here and to hear your presentations. I will now hand it over to Joa to round us off.
Yeah. Thank you, Janet, and thank you for this moderation. Really great. Just wanted to finish up by thanking everyone that participated, everyone that submitted, everyone that was in these 3 sessions, either online or in the room. That I can see that there are some people out in the back because the camera is not the best. But I would like to thank them all. I would also like to thank the organizers, Janet, Jason, Moritz, Stig, Sergio, and Tiago, and of course the organizers of ICCC for giving us this place to host our workshop, in particular to Pierre, Pablo, Dan, and Hugo, and the local people that have set up the remote thing, which is not always easy, but in the end it worked out perfectly. And to everyone that is still here and is listening to us, we have a Discord channel, and we plan on doing this again. I'm not sure if in 1 year or earlier, but we would like to welcome you all to submit again and to join us. And if you want to collaborate, there's space for that. So just reach out to us. And if there's anything else, feel free to say. If not, I think it's too much screen for today, at least for me. And I say bye to everyone. Okay. Enjoy ICCC. I think there is a watch party for those that didn't have enough screen. For me, maybe another day.
The watch party organized by Luis in
Yeah.
Discord.
Yeah. Bye-bye.
Bye.
Thank you all. Bye.